All right, welcome everyone. I want to first bring your attention to the audio delay. This is really intentional. We're trying to make this as difficult as possible for you to watch. Nah, not really. It's I'm not at location. I'm at a different location at the moment, and the result is that I don't have. I got my really good equipment, but I don't have my webcam, and the webcam allows me to sing. So anyway, welcome to Friday night 3D printing community hangouts, F3DPCH, hashtag F3DPCH. On the panel tonight, we have David Randolph and we have Matt he's from You Do It. No, he's John from You. No, he is, he's Matt from How I Do It. All right, so tonight's topic is 3D printed robotics. Now, this is a topic that we already discussed, and you might say, well, you already talked about this. There's so much that we could talk about in this topic, and I was really inspired by the stories I heard from people afterwards, and they said it was a great topic. So I figured we would continue on this. I attended the Printed Solid meetup, which they have periodically, like maybe once a month, once every 3 months. They're in Newark, Delaware, printedsolid.com. And Matt and I were talking with David Randolph, and we asked if he wouldn't mind joining because David is well versed in many things. He does so much; it's incredible. He is a very inspiring individual. I wish I had his whole bio sheet. It could probably take me about a half an hour to get through everything that he's done in his lifetime. But one of the cool things that he's working on right now is droids. So droids from certain movies like Star Wars, and it's really an exciting topic. He not only is investing a lot of money, but a lot of time, and he has a know-how, and the know-how that he doesn't have, he gets from a lot of collaborators in his group. There is, if you didn't know, a droid builders club. I'm not going to go into too many details because I'm going to let David tell you all about that. So I'm going to hand this over, starting from my right. I'm going to go right to Matt, and then we'll head right into David. So we're going to tell you, they're going to tell you who they are, how to contact them, what they do, and there you go. It's yours, Matt.
Hey, everybody. I'm Matt from How I Do It. I do a little bit of everything, 3D printing, metalworking, woodworking, just general DIY. I'm always tinkering with something. I'm always trying something new. And my YouTube channel, Twitter, Instagram is just my way of showing you how I go about doing something. Doesn't mean it's the right way. Doesn't always mean it's the proper way. I try to do it as proper as I can, but sometimes you just got to wing it, and maybe you might learn something along the way. The other thing I do is organize the Friday 3D printing community hangout streams on the Facebook groups and through Twitter. I know today, this week, I've been a little bit lacking in getting the information out just due to some personal events going on. Nothing bad or anything like that, but just things that are eating up my time here this week. So hopefully, that'll go back to the usual, that I'll be announcing things throughout the week. And the other thing that I have that's been eating up some time is we're preparing for the EARTH 2018 convention in Bel Air, Maryland, which, for those of you who don't know, that's the East Coast Rep Rap Festival that was inspired by the Midwest Rep Rap Festival that's held in Goshen, Indiana in March each year, put on by See CNC in their hometown. So what the Friday night hangouts are doing to prepare for EARTH, we do have a sponsorship table at EARTH that was generously donated to us from EARTH, from the guys and gals that are putting on EARTH. So over the last couple of weeks, I've been trying to think, what can I do for the Friday night hangout table? And John has graciously made the banners that were visible at MRF, and he's working on, I believe, banner number 2 in preparation for EARTH. Is that correct, John?
It is, but I don't have enough input to prepare banner number 2 yet, so I'm not going to hit the go button if we don't have enough to fill up the banner.
No problem.
So I might prepare it for Murph.
Okay.
Sure.
So John's been making these banners, and you know that's great, but it wasn't enough for a table by itself. So I was inspired by the conversation that we had 4 weeks ago, when we did the community builds topic on my channel for the Friday night hangout, and talking to We the Builders, talking to Nick from MakerBox, and how they did their community builds. And it gave me the idea to take the Friday night 3D printing community hangout logo and scale it up. And man, did I ever scale that thing up. We're going to be, we've been for the last week now putting out parts by request by email, which you can email the Friday night 3D printing community hangouts at f3dpch@gmail.com. And I'll post that in the chat here in a little bit. You can request a part. All the parts are 125 millimeters by 125 millimeters by 50 millimeters tall at the largest. So most any printer can print them. There are some smaller pieces for people who are either on a time constraint and don't have the print time available to them, or have a smaller yet printer that they can't print something that big on. I don't think there's too many printers out there like that, but there are a few. So we have a couple of different sizes, but you can email the Friday night hangout to get a piece that will eventually, actually I can hold this up. I could do a screenshot, but this is quicker. So this is the grid of the logo. It's going to end up being 4 foot tall by 6.5 feet wide when it's all said and done. It's made up of 152 pieces. And at last count, which admittedly would have been late last night, we were at, I think, 79 pieces. And I know a lot of requests have come in today. And I want to apologize to everybody for not getting to them today. I actually will not be emailing out any parts or accepting any parts until late tomorrow evening, just because, again, of some personal stuff I've got going on today and tomorrow. But sending out parts and approving parts will resume tomorrow evening. So if you've sent an email, just please be patient with me here for a little bit so I can take care of some personal things. But they will be coming to you, or your parts will be approved, and you'll be able to ship them out to us. We are asking that the parts are shipped no later than June 18th. And it is possible to bring them along to Earth as long as you can guarantee that they will be there within 2 hours of the start of the morning on Saturday. Now, I will be down Friday night and first thing Saturday morning as soon as I can get in the door. So if you can bring them along, that's fine, to save on shipping costs. But please correspond with me via email, so I know who's bringing parts and who's shipping parts, and we can go over any details. I know I'm dragging on. I'm going to wrap this up really quick. There has been some questions as far as, do the parts need to be printed in any certain color? They do not. A lot of us are printing them in the colors of the logo, which are black, orange, tan, and silver or gray. But that's not a requirement. I'm doing it just because that's the way I want to. We do have some people who are printing them in multiple colors, but like Heather from Apyro Designs is going to be printing them in 4 different shades of pink for her pieces. And I will give you a hint. There are some contests going on, one of which we've already announced. If you do have a failed print, keep your failed print. If shipping or weight limits getting to Earth allow you to, please bring your print along. We're going to let the attendees at Earth vote on the most voted failed print. So we'll have a failed print favorite at Earth. The prize is actually sponsored by Printed Solid. The winner of that contest will get 1 kilogram spool, a 1 kilogram spool of the Printed Solid Daily PLA. That was donated by David and Matt over at Printed Solid. There are 4 other contests or giveaways going on, one of which will be a giveaway to all the attendees at Earth. That's going to be a $50 store credit to Protopasta, sponsored by Protopasta. Go ahead, John. Oh, you're centering yourself. So Protopasta sponsoring a giveaway open to all attendees at Earth. Printed Solid is sponsoring another spool of daily PLA, and the hint for that contest is creativity is encouraged on your pieces. And then there's 2 more contests that have not been announced and will not be announced until all the parts are in, that are also sponsored for $50 credits to Protopasta's web store. So that's 2 more giveaways. All the contests have to be, you must print a part in order to be entered. That's the only stipulation. You've got to print a part. You do not have to be present at Earth to win. The giveaway to the attendees, obviously you got to be present at some point throughout the weekend in order to enter, but you do not need to be present when we actually do the drawing and announce it. So that's it. I'm going to wrap up because I don't want to drag on halfway through the stream, and let John move on to David.
It's all you, David.
Oh, okay. Hey, everyone. This is David Randolph. I'm a co-owner of Printed Solid with Matt Gordon, and figured to come by and show you what I do in my off hours. You can always reach out to Printed Solid through our Facebook or our Twitter pages. Most of you are definitely familiar with us. And we, of course, will be over there at Earth as well. We have 3 booths total. We have quite a few booths there because we are now the owners of MakerBox that you mentioned earlier. So, which is a lot of fun. So you'll see us there as well, which is nice. So, quick background on me. I've been the owner, or one of the co-owners of Printed Solid for almost a year now. July 1st will be my official 1-year anniversary with of actually owning part of Printed Solid. Before that, I ran a laser cutting business for the longest time as a part-time, and I was doing engineering work for different broadcast and internet companies out in California. So quite a few other diversities in there. But as far as for tonight, I spent a lot of time with droids and robotics building. I fought combat robots like BattleBot, stuff like that. One of our laser operator actually just came back from this season of BattleBots. So if you watch that, you'll see that, and some of the parts in that bot were printed, in our shop and everything like that. So we've been helping out with that. And we recently did he's an employee of ours, and I actually went as crew, so he got to tell me what to do for the day, which was nice. But he went out and fought a couple of 100% 3D printed combat robots on the East Coast at some competitions, which was a lot of fun, and actually generated a lot of interest. And Ninja Tech sent out some of their engineers to come check out his bot, and they brought a bunch of their filament with them, their armadillo filament, and actually printed a lot of his bot parts for him as well, just so they could make sure that it was as strong as humanly possible and make it look really good and all that fun stuff, which was very entertaining because since these parts can be 3D printed for him, he actually had like 6 frames just sitting there on his bench. So every time he'd fight, he'd just swap out the whole frame and go fight again. It was kind of fun and entertaining to watch. So we do that. And like John mentioned, I'm also in the Droid Builders Clubs. And rather than list off the Droid Builders Clubs, there are literally dozens upon dozens of them. And they usually are extremely regional and very specific. I belong to the BB-8 Builders Club, the Middle Atlantic Droid Builders Club, the Mouser Builder Club, the Goink Builder Club, the R2-D2 Builders Club, Astromech. So it takes you have to kind of go through all the different clubs to get all the files and get everything organized and do all that. And it's kind of funny because while I do enjoy Star Wars, I don't consider myself a Star Wars fanboy. You're not going to find giant, Han Solo stands and Boba Fett stands around my house, but you'll find droids because when you go to the droid guys, they spend a lot of time on the mechanics of the bot. It's not so much about the movie for a lot of these builders. It's a lot about the process and figuring out how to make it actually do what's in the movies. There's been it's really fun to see the development. We do a lot of like this is my BB-8 back here that I've been working on, and this is the drive system for it because you can't really. There was never actually a real working BB-8 in the movies. They made a stage version, but they never actually made a working one. And there's a lot of droid, especially in the BB-8 club. It's a really hard mechanical thing to do to drive a ball around. And the fun thing about those organizations is how much they actually, how much time they actually spend trying to make it be exactly like the movie and be what it actually is. So there's people that are working on just the little lighter that BB-8 sticks out in the movie, and there's people that now, because of the last one, they're trying to get coins to be ejected out the side and stuff like that. You get into the R2 clubs and you start to see there's people that make the entire bot so it can go from 2 legs to 3 legs. There's people that make the bot have every single thing flail up like it's being electrocuted, all the digital arms and everything like that. It won't be long before we start seeing people try to figure out how to make it fly with little rocket booster packs come out of its legs. So they're a fascinating group because they use the movies not as to be necessarily fanboys, but as technical references, and it's fascinating to meet with those guys and see how anal they get. Just the dome on the top of the BB-8 there is about 10 variations that most people consider reasonable out there. Most of the builders would consider reasonable, but there's an argument on spacing of the lines and how thick the lines need to be. And we're talking millimeters. And these are people that are doing screen grabs of the movies just to try and get it mechanically perfect. There is a great argument out there on whether the dome should spin at that line or that line, just because of in the movie they accidentally did one scene where it spun at the other line and now it screwed everybody up. So it's an entertaining organization just for that reason. We have a lot of fun with that. Oh, I'm just kind of looking at the chat while we're chatting here. But yeah, the BB-8 prototyping is a lot of fun, but dear Lord, it takes a lot of filament. My humor story of that is that, well, heck, I own a 3D printing company, so filament shouldn't be a problem. But since I do technically have a business partner, he cringes every single time I leave because I'm usually taking a couple extra rolls and say, taking these home to work on BB-8, make the next version. So I probably go through, at least 3 or 4 rolls a week just trying to figure out BB-8 and his stuff. Someone asked, how much does it cost to build a droid? Well, I'll tell you this. There are people that have well over $10,000 in their BB-8. So I'll tell you this. Just this drive system, not even the frame, is $3,000 to me. And that's because I get the filament for free. It's just the electronics and all the other custom parts. And this was actually designed by one of our customers, Dave Fiera, who has been doing brilliant work on this. And he's been basically sending me a lot of the parts, so it's been great. An R2-D2, you're going to see between $3,000 to $20,000, depending on how crazy you go with it. So you'll see a lot of differences there. There's some cheap, BB-8s out there, but sub $1,000, things like that. So, and as far as what type of motors, it's actually a bunch. And the reason why is because, give me 1 second here. I'm going to bring the camera over to show you a little closer view of Dave's drive system, which is an absolutely gorgeous drive system. There's a servo here, so that's to pan left and right on just the head. That's just the head sits on a rod here. There's a servo here that turns the head. Then there's a servo here for the pitch of the head, and then there's a servo here to control left and right, or to move the weight left or right to drive it. And then there's actually a brushed motor with a gearbox that drives a flywheel on the bottom that that stabilizes everything. And then there is another giant motor on the back that drives a belt to a bevel gear that comes out to these rods here, and that's what actually drives it forwards or backwards. That's just the drive system for it. That's not included any of the other motors for any features or anything on it. So you can quickly see how there's a lot of them on these designs. So the diameter of the base most BBS enthusiasts build towards. Well, the body itself, give or take, is about 24 inches around. Most people reasonably want at least a 250 by 250 build volume for everything. So bare minimum. That body there, just to give you a scale of it, that is about 10 kilograms of filament for everything that's on that. And this, to answer Chris's question, is this is version 3 that you're looking at here. Version 4 is sitting in a box over there. And I already have new files for version 5. So there's a lot. Someone asked a quick, preview of my printer farm. My workhorse has always been the TAS-6. Most of the body has been on the TAS-6, and most of the mechanics has been on the Ultimaker 3. I use the Mini whenever I need to do kind of small ABS parts. The Prusa's, I use those primarily just for other stuff and to play with and no Prusa's. I got a cute monoprice Delta that was a drunk. It was on sale. I forget which holiday it was, but I was drinking and I was like, sure, I'll buy it. And then I have the CR10 S5, which I'm still doing some modifications to print even bigger stuff for fun. But and then of course I have my giant raised printer over here with my little hood on top of it for kind of bigger prints and stuff like that. So a little bit of everything. So that's kind of my 10 cents on droids. I will say that it's been about 5 years, but I fought a combat robot in the heavyweight division that was called it was called Simba's Revenge. I really like to go with screwy names for my bots. And it was Simba from the Lion King. So I had a big Lion King picture on it, and it was really just to kind of mess with the other guys. And I 3D printed all of the internal separators and mechanics and battery compartments and everything like that out of ABS, so that when it was in combat, it was a lot safer. And the main reason why is because you get into combat robotics, which is another example altogether. If you get into combat robotics, the heavyweight division is up to 220 pounds for the bot. So you can imagine building a 220-pound robot, then driving 40 miles an hour and slam into another 220-pound robot that might have a saw or a hammer or something like that. You need to have the internals really safe. If any of you ever watched any of the BattleBot shows or anything like that, almost every episode you see some bot smoking. That's usually because the batteries inside either exploded or they shorted out against the frame and they're burning up. So that's usually where the smoke comes from, and that's because usually what happened is they were impacted so hard that the electronics or the battery or anything like that literally just smashed against the inside of the frame and ruptured. So those are a lot of fun.
That happens.
Yeah. And then the other bot that I built not too long ago, a little shorter than that, was called Super Fluffy Pink Bunny from the Land of Candy and Rainbows. I did that one really to mess with people on multiple levels. I actually painted that thing with sparkly pink paint, and actually found a additive to make it scratch and sniff, just to really mess with everybody in the pits. If you know me, that's my humor. And it had a fluffy bunny in a little cockpit that you drove, so that every single time, it was a wedge design, so every single time a bot would come up, they'd be driving over the bunny and hit its little ears that were sticking out at the top. So, and I had every bot that had a flamethrower was trying to burn the bunny up in all the fights. It was really entertaining to go out and fight that. I got knocked out a little early in the competition, but I brought a ton of stuffed bunnies with me to the competition, was kind of throwing it out to the audience and everything like that. And all the other bot builders started duct taping the bunnies to the front of their bots to go in and fight each other. So unfortunately, the arena people weren't too fond, just because they had to go in there and sweep up all this fluff laying all over the arena after the fights. It was very entertaining.
That's great.
But yeah, that's kind of my intro spill, what I do. And it's kind of funny because this is my this is what I do when I'm not selling or fixing or repairing 3D printers.
Jeez, that's a lot. So I'm going to divert right now to Richard. Richard joined us late, so Richard, can you give us your intro?
As soon as I find the right button. I'm Richard Murray. Channel is the Zadim channel. I've been away from things from about 6 months, but I'm getting back into it. The main focus is 3D printing for model trains, and I'm gotten into the wonderful world of SLA printing. But I'm just watching all those nice robot parts there and drooling away. And I definitely want to pursue that some, but I got all this train stuff to get out of the way at first. So yeah, the channel is the Zadim channel, and I'm on Facebook. The best place to find me on Facebook is 3D Printing for Model Trains. That's about it.
Can you post that link in for the Facebook model trains, Richard, in YouTube, in the live stream?
Yep, I'll get
all
that.
Right. So again, if you're joining, I apologize for my audio. I am off location at the wonderful Jersey Shore, and I forgot my webcam, so I'm using my Panasonic G85 hooked up to my Elgato HD60 capture card, and there is a noticeable 1.5 second audio delay, which I thought I had figured out in OBS. Turns out I'm only using the virtual cam in OBS, but the audio comes directly from the microphone, and therefore I can't delay it. Google Hangouts unfortunately doesn't have any mechanics to delay audio. So 3D printing, to me, really opened up my eyes. I built a CNC machine 10 years ago, with a rigid router. It was, I've been tinkering all my life and building stuff, and so that really got me someplace. And I intended to do that really to help out with my in-scale model layout. But then I got into making signs and everything else instead of doing anything for model trains. Then I switched to 3D printing. Well, I didn't switch. I'm complementing it with 3D printing. I got my printer in April of last year, so it's been over a year. And 3D printing has really opened my eyes to so many different things. So I'm a woodworker. I found that I can use 3D printing to create any type of jig that I need to perhaps drill a perfect hole, like Craig has their jigs. But, crap, if I need a specialized one, yeah, sure, I'll whip it up in a live stream in Fusion 360 and 3D print it and use it. And I needed to get a hole directly in the center of a transition board, so I use 3D printing for that. So 3D printing, my point of going into this thing, chances are you already know about 3D printing, because that's why we had this Friday Night 3D Printing Hangout. This is to those who don't know, who may be watching on the replay, what 3D printing is. So 3D printing, there's several different types. We have additive and SLA. A couple other types use resin. There's some sintering types where metal is deposited. So a lot of cool stuff. So a lot of the printing that you saw David talking about was FDM type printers. So we are talking about robotics in 3D printing. So if you're just joining us now, we're talking robotics and 3D printing. This is kind of the continuation of the last time we spoke about this about a month ago on my channel. And I was at the Printed Solid meetup, and we talked to Dave about it, and we all know that Dave does some crazy stuff, so that's why we invited him on. Okay, we have Geek Tech has joined us. So Geek Tech, give me a signal if you're able to talk and use your microphone. Okay, so we're going to switch over to Draco and let him give us who he is and where you can find him.
All right, guys. I'm Draco from Geek Tech. I've been on YouTube for a couple years now, kind of just nonchalantly making my way through. I do a lot of very nerdy things, about as nerdy as I can get it, as often as I can do it. I play a lot of video games. I do a lot of prop making and stuff like that. I've helped out with several different cosplay groups throughout this area that I'm at for different conventions and stuff. But I currently do not have a working 3D printer, and that being said is because one of mine is down. But one of the big things coming to my channel right now, which is Geek Tech, it's spelled kind of strange, but it'll be in the description. I'm working with a company called ZYL Tech or Zell Tech, whichever one. They recently designed a hypercube. It's a Core XY printer, and they just sent it to me. It's actually sitting behind me on a table. I've been knolling the pieces together, but we're going to be doing a build tutorial on the printer on my channel to kind of get more people into it. It's a fairly decent XY printer. I'm not going to say it's one of the best ones that are out there, but it's a decent kit to get you actually into the whole mechanics of building actual kit printers. It's actually not bad. But yeah, that's really me.
All right, thank you for that. All right, I'd like to talk more about robotics. So, Dave, out of everything that you've done, can you tell us what has been the most challenging in your robot creation, and what was the most fun out of all the things up to this point that you've created?
That's a good one. So what I would probably say is that when it comes to it, the biggest challenge is kind of helping out and working, or really following, because he's been leading it. The hardest has been the drive system for BB-8. That's been probably my hardest 3D print, concept right across, or build across the board. And the main reason why is strength. It's the biggest problem with robotics. There is a lot of problems because we know different materials and things like that. And this bot here, which I also use to kind of demonstrate at different part shows, different material strengths and the importance, has almost every material known to man on it at some point or another. There's some ABS in there. There's some engine in there. There's even some PLA for less strength stuff in there. There's some Ninja Flex in there. There's a lot of materials in this. And that's the thing, is I think robotics, as far as 3D printing is it's not so much about the machine, it's about the materials. I've seen people with, the really cheap machines that as long as they can get the material through it, the robot is going to be, the robot's going to be great. It's just getting the materials right. I opted for a lot of parts in engine just because it's kind of the happy medium, being pretty strong but dimensionally accurate. I find that ABS shrinks a little bit, so I end up having to machine the parts separately. So those are so that's a little bit of a challenge with ABS or even ASA, making those type of things. Now, as far as probably the most fun that I've had, I love building the kind of the battery boxes and little terminal protectors for all the bots. As weird as it sounds, there's a great amount of satisfaction because of building these little things. Even if it's just a freaking box, there's a great satisfaction for designing it, hitting printing of it, and having it. You can talk to a machinist, and a machinist will sit there and tell you, they'll work for 8 hours straight making, a small screw offset adapter and be very proud of it. It's the same concept of 3D printing. So I'd probably say it's been the little things that I designed for the heavyweight bots are my most fun. And my biggest challenge has been able to make this mechanically move, because on the bottom of it here, this sucker has a 5-pound flywheel spinning around to stabilize it, and everything hangs off of that. So this machine, this here, sees a lot of torque on all the axes and a lot of wear and tear on the printed parts. And when you take this sucker out, you don't want anything to break. We've been, Dave's been designing stuff, and he tried his best to actually make this one motor all 3D printed, or this one part. I'll kind of zoom in there, but he tried his best to make all this 3D printed, and it was too much for it to handle to actually take the flywheel while it's spinning and still tilt the whole bot on that. So there was too much torque, and it was starting to crack, and there was no material that was strong enough for it. So he ended up having to switch over to metal for that. So it's tough because, owning 3D printers and loving it and all that stuff, and owning a 3D printing company, I want everything to be 3D printed, but sometimes you do have to compromise and realize there's going to be some times where you have to use a different material.
Dave, with your robotics, how hot does it get inside? You have multiple motors in there. I imagine that would have some impact outside of the actual burning and the combat robots, but just your materials inside are going to get exposed to a lot of heat, I would think.
Absolutely. There is a benefit in combat robotics. The match is only 3 minutes. So it's not so bad. Usually those connectors do get hot and they're throwaway. So I'll print out a big old box of them and have them as spares, and then just swap out whatever melted during that fight. And if you didn't know combat robotics, that is a big part of the pits, is that between fights, you've got 20 minutes to fix your bot. If you see that bot has been cut in half, they say, well, you got 20 minutes to get that bot back together to get to the next fight, or you're disqualified. So you get into these pits, and for me, even just having organizers for nuts and bolts sitting on the table helps tremendously. Having jigs sitting around holding all my tools is a big part of it at these events. So, and you take tons of spares. And just as a side note, the one thing that always cringed at me in the combat robots is that I might spend $300 to $1,000 for a single motor for these bots, and there's builders that each motor is worth one fight, and they intentionally overvolt it or overamp it, burn that motor out in 3 minutes, and then just throw that motor away and then put another one in. So it can cost a robot builder $1,000 for a single fight, even if they win and don't take any damage.
Yeah, I think that's rather expensive way for a hobby. But for something like BB-8 there, where you hopefully will have it running for longer than 3 minutes, and what's it like for that?
Well, these, you're expected that you have about 20 minutes of runtime on a battery. And you'll pretty much have to open it up and air it out, but it does get warm inside. The PLA parts, I would say, as long as it's not structural, it's perfectly fine. So I'll use it for wire guides and protectors just to kind of prevent stuff from falling out of the way. So, but yeah, PLA definitely, I would not want to do it. Even if it had the strength, I wouldn't want to do it just because of its glass temp.
Cool.
But I think that, by the way, that's a great subject if you've never really addressed it, is the glass temperature of materials in 3D printing. A lot of people forget about that. So when you think about the application of where you're going to put it, you know, always look at your glass temp and consider that that is the hottest you ever want that part to ever get ever again.
Oh yeah, you get that with some of the smaller motors. I haven't had it lately, but I know I've had some locomotives that you run them for an hour, you know, at the museum, for example. It gets hot for that stuff. So you got to be very careful with what you're going to use for detailing the parts.
I recently talked to a client about trying to get higher temp stuff out there, and it's tough finding anything above 100 C to deal with. So most of the time when you get to 100 C, that's about average for most 3D printed parts if you get good materials.
Well, going back to your combat robotics, what's the most robust batteries that you can get?
Lipos. Most of the time, I'd probably say some of the more popular bots out there are running on at least 48 volt lipos, and they will fully drain them in 3 minutes.
Moving a lot of current.
A lot of current. I'd say 100 amps at 48 volts is about average.
Holy crap.
I've had a couple bots accidentally weld themselves together. I had one year I had one bot that actually welded the positive terminal of the battery to the top of the bot, and it had me kind of crapping my pants, pardon the French, but because I couldn't get the top off of it to surface it because it was welded together. So I took a giant pry bar, pried it off, cut the wire, and had to quickly remake it all.
So I want to acknowledge Robbie McHugh said he loves some Robbie. Right, what'd you say again? He loves some Robbie Q robots. So that was I really appreciate that $5 donation there. That's not expected, and oh my god, yeah, it's incredible, guys. Thank you. Colin makes stuff, and he's like, here we go, because apparently there is a race now. Who's going to donate what? So look, I appreciate it, guys. I should have Streamlabs up and running right now. But I will in the future, and apparently all that stuff is memorized, so we'll see all the donations coming up. Appreciate the love, guys. We will keep talking robotics because this is it's an awesome, exciting topic. So let me pass it to the others. So Matt talked about his K2SO before. You got that? You could talk about that a little bit?
I can. I don't know where the base got to. So, I mean, you let me talk about this after Dave, right? That's going to like put this to shame. So yeah, full size K2SO head. It has an Arduino Nano or Micro, I forget which one, inside the head. And the Arduino is doing a couple of things. It's just driving the lights in the eyes. Give me a second here and I can plug it in. You might be able to see it. Lights in the eyes. There's lights in the side of his head that all light up and flicker, which could have been done simply using like flickering LEDs. But I liked being able to do the randomness of this, and you might have been able to hear that. So there's lights in the eyes, lights in the greeble on the side here to make it as movie accurate as possible. But then in the bottom, right here, in the bottom of his head, there's actually a servo motor mounted in the bottom that mounts to a base. So when he's actually on his base, the head will completely random, using a random number generator on the Arduino, change the delay between moves and also the degree that his head moves. So this one's not tracking anything across the room or doing anything fancy like that. Though sometimes it's really odd when it is plugged in and running, because it'll be looking across the room one way, and all of a sudden you'll walk in the room and it'll turn and look right at you. This was my first foray into really playing with servos and DC motors of any kind to do, so to speak, kind of an animatronics idea. This will get built on in the future when I do my C3PO head. That will evolve taking this idea and code and actually track things in the room as people walk through the room, or my dogs walk through the room, whatever the case may be, that it follows them and tracks them across the room and talks to them. That one, when I get to doing the C3PO head, that one I plan to pack as many electronics into the head as I possibly can. That one's a little ways away down the road yet in my projects of doing all the Star Wars droid heads and helmets from the movies. That's really the only robotics that I've done for the most part. I mean, technically you could count my camera slider too, but I'm actually currently in preparation and planning for version 2 of my camera slider. And then I also have, this is a in the works project, but I'm not really doing too much with electronics on this one. I have a big remote control truck, one of the Radio Shack specials from back when I was 16 years old. Somehow it survived my teenage years. The first thing I did to this, and it's not even in there, of course. First thing I did to this was to upgrade it, take it off of NiCad batteries or nickel metal hydride, whichever one. This used the 7.2 volt typical RC batteries that are 6 inches long and 2 inches wide. I 3D printed an adapter for it that can take 4 18650s to give it a little bit of a speed boost, power boost. And the next step for that is going to be tearing it down and 3D printing a new chassis, frame, everything for it. I'm going to slowly build it up into sort of like an F1 car, but something probably lower profile than the truck. But I'm going to reuse all the existing electronics in it. I just want to kind of a adventure into remote control vehicles and 3D printing. I think that's, for the most part, as far as robotics go, that's pretty much the extent of what I've done so far. But there's always the possibility in the future of expanding that one, of course.
I'm doing
if anybody's looked at building some robotic arms, you know, the third hand in order to hold parts as you're working away.
So that's a good segue into what I want to show you. There's so you know, we had Ross Rohrer on You're Down for What. He built a robot arm with an effector that could grab things. There's a YouTuber I came across who appears to not be too active on social media. Disappointing. Again, we're trying to get Chris Riley on Twitter for instant access. And he goes, his name is Chris Anin. See if I can bring up his channel, and I'll switch to displaying my screen here. I reached out to him yesterday, which was clearly not enough time for him to do anything, to respond, because, you know, it doesn't appear that he responds rapidly to Twitter. So let me switch my display. I want to make sure I don't. Let's bring the Hangouts someplace. Okay, we'll take that out of the way. So I'm going to talk about this, and then I think it looks like Dave is getting ready for something. So let me know when you're ready. I'm going to talk a little bit about Chris's page here, Dave. I just want to get my OBS set up so I can do that. Let me know if you can see my screen, if it's looking good to you. This is Chris's page, and he does a lot with robots, and it appears that they have some type of software, whether he contributes to it or somebody else created it. It's this AR2 software that allows you to plug in a lot of things to control it. So I think it has all the kinematics already figured out for like 6 degrees of freedom, and you can reduce the degrees of freedom. But this degrees of freedom includes the base rotating, the arm coming down, the next arm coming down for the next axis, and then the effector on the end for clasping apart to being able to pick it up. He has a lot of videos on here, and this is kind of what inspired me, along with David's droid background, to continue this topic. And I think we will find more about 3D printed robotics, but this is all 3D printed robotics and talking about the kinematics. So I went to Drexel for electrical engineering, and I specialized in robotics. And I remember going through by hand all the kinematics for 6 degrees of freedom, and it's a lot of math. But what you had to do on paper is done more easily in something like MATLAB now. And apparently with this software to kind of like take the guesswork out of all of it. So, Dave, do you want to talk about your stuff?
Sure. What I'll show you guys here is, by the way, if you don't know these guys, there's a company called Servo City. And they actually make, it's kind of the go-to when you need, parts and all that stuff. I really like those guys for that. But I just want to show off this little controller they make, which is probably the simplest controller you can possibly get out there. And I use it for just checking servos and motions, because you don't want to deal with the kinematics and the programming and all that stuff until you know it's actually going to move right. So I like this box because you just hook up the servos directly to it, and you get a little joystick to control it. So, for example, that I have my servos, they are programmable servos, so I can set mechanical limits or software limits on everything, but it lets me actually drive my servos and make sure that they'll move and not get caught on things. An example is like here, Dave had to design in these little notches into his design so that when this tilts, the motor and the cables and all that doesn't actually interfere with it. And stuff like this is a really great way to quickly check to make sure everything actually works. And what you're seeing now is that this is just what controls the head. These two axes is just controlling just the head that sits on top of the bot. And then I'm going to set the camera down here for a second so you're going to get an ugly view. But if I hook up the other servo, now this is what controls the tilt of the whole bot. So it has to move everything all the way left and right. So there's a lot going on with these things, and I really like that cute little box just for testing and calibrating out servos. It's $100. It's worth it just so I don't have to sit down and program or get a controller and do all that work to set it up just before I actually have to do something.
So, Dave, I have a question for you. Building kind of, so that's good for testing your servo, because like you had to do there, you had to switch around the wiring and everything. So testing your servos, testing the gearing, testing all that stuff. What, for somebody who's looking to get into robotics, not necessarily something on the full scale of like an R2-D2 or a BB-8 with so many different axes of control, essentially, what do you recommend for somebody looking to get into the RC side of robotics, as far as like a controller and radio receivers and stuff? Sort of like an entry level, but still not like the most beginner thing you can get. Like not just having a up and down and left and right controller. You know what I mean?
That's a tough one because there are so many options out there. It depends on the person. I pretty much every time I build a robot, for some random reason, I end up picking a different controller, and I kind of have to learn a whole new language and figure stuff out. I mean, Arduino is the default, of course. I mean, everyone knows Arduino. It's usually the default, but sometimes it doesn't have the speed or what you need to do. An example is like on the BB-8 stuff. I am not even taking care of the coding on this. There's another guy that's handling the software programming for this, because this unit will have 2 IMUs on it for stabilization, and Arduino doesn't respond very well to that fast of a stabilization. So they actually have a different controller in here just for that, and that's a C# language, which I have no clue about. There's a different controller for each thing. I would probably tell if people wanted to get kind of started with robots, the first thing I would probably suggest is a line following bot. Arduino is probably the best starting point for most people. Main reason why is because they don't have to worry about servo positioning, which is a whole skill set in and of itself. And they can kind of work with DC motors and learn basic power concept, basic motor concepts, and then do a little bit of intelligence with line following. Basically, little light sensor that picks up in light or dark and tells the motor to do one thing or the other. So it's a great starter. Then I usually tell most people after that, build a sumo bot. You'll learn a lot of good mechanical properties after that. Main reason why is because sumo bots, they don't get destroyed, they're simple, and they start to teach you a little bit about RC stuff. So you start picking up a lot along those lines. Then after that, you can go after the heavyweights and waste all your money.
Cool. Thanks, dude. Country 3D Walter said he can help you with your C# if you need it, if needed too.
Yeah, like I said, this part here has been Dave Fiera has been definitely heading this project up, and I've been following along. I am working with him primarily to help him with documentation so that he can get it out to other people to build. So I get to do the wonderful job of trying to figure out how to put together what he already did with no documentation.
Yeah.
I've invited him up to crash on my couch on multiple occasions to kind of help me build it from his head and then record it so I could write the documents later.
It's sort of a different kind of direction a little bit with the topic tonight. For you personally, Dave, what's the most complicated robotics that you've designed yourself without crowd working on it together as a group? I know, like with the BB-8s and stuff, you have your droid builders clubs. What's the most complicated thing that you've started with nothing and designed up yourself?
Way back in the day, I used to work for a museum exhibit company designing interactive children's museums for science museums and stuff like that. And I did a lot of dinosaurs. So large format dinosaurs, primarily pneumatics, and that type of fun. So, and back then I was a horrible welder, so I had to go back to my welding guy and tell him exactly what I wanted him to make and how to make it, have him make it, and then I would go rig it all up, do all the hosings, set up all the solenoids, and actually, and then do the individual programming for that. At the time, there was a company, I just forgot the name of them, that made a controller that was actually a linear scripting program. It actually gave you a timeline to program in and gave you each motor, and you just sat there and just tell it what you want each motor to do at what time.
Huh.
Cool. And it was really cool. Did a lot of that. And I was bored one night not too long ago, and I remember pulling that old controller out. And I did a podcast back in like 2008 with it. And I programmed that controller to play Guitar Hero, and make 100 points on it. So I just sat there and had a bunch of solenoids pressing the buttons to win at Guitar Hero because I have zero coordination.
That sounds like my way to play Guitar Hero.
It was funny because to actually get the programming for it, I recorded it, play the song, and took it into Avid, which is a video editing program, and I could find out exactly how many frames it took till that button came on the screen, and I could write down the time to say exactly 2 seconds in, fire this button for this long.
Nice. For robotics at its finest.
Yeah, it was a hell of a cheat. Which, by the way, if anybody wants to do robotics, that's the first thing I would tell you. Don't be ashamed to cheat. Don't be ashamed to do things weird or long or the hard way and cheat at everything, get lazy. I've seen a lot of robot builders. They go down to Harbor Freight or Home Depot and buy a Ryobi drill, tear out the motor, glue the clutch together, and that's a perfect drive wheel for something.
That's an awesome idea. I've seen them do that for drives for like the ride-along coolers.
It works great. You'd be surprised. I mean, if you go to Harbor Freight, they have a $20 drill. The motor inside of it's worth $30.
Nice. I've bought. I have a box over in my workshop of DeWalt and Ryobi just because I have batteries for those tools. Drills, I go to auction and buy them where the chuck's screwed up or something like that. That it's no good to somebody who's buying it as a tool, but yeah, like you said, the motors in those tools, especially these 20-volt tools and stuff, I mean, there's some beefy motors in these things. So I pick them up that way for 50 cents to $1 in a lot of cases.
Oh, yeah. I recently decided to move away from the Ryobi 40-volt lawn care products. So I have the trimmer, and I have the blower, and I have the actual mower. And nobody will buy it on Craigslist, so I think I'm going to just tear them all apart and take the motors out and build a bot.
You were talking about the battle bots, and I just bought that Ego 56-volt, and then you got one.
I blame you.
What was that?
I blame you for that.
I'll take the blame. I just bought the Weed Whacker last weekend, by the way. Has anybody, like BattleBot-wise, taken something like these electric mowers? Because you were talking about that, and honestly, my mind went right to my mower. Flip that sucker over, put bigger wheels on it, and take the blade guards off. And now you've got a killer BattleBot.
There's a great guy, his name's Chewy, that actually makes, he prides himself on making bots out of, found parts. The last Robo games, he actually took what he called Butterbot, which is the butter robot from the Rick and Morty show. And he made a giant one with a flamethrower to go fight. Nice. And it was all old DeWalt drills driving it around the arena.
Oh yeah.
So there's a lot of that going on. There's a lot of recycling. My favorite is that if you go to like the Ryobi batteries, they're using these lipo cells, these generic lipo cells inside of them. And if you buy the individual cells and make your own packs like the robot builders are doing, they cost a fortune. So robot builders are going to Home Depot, buying these packs, tearing them apart just to harvest the cells from them.
Yeah, they've got 18650s inside the Ryobis.
And those things are worth way more than what you pay.
Yep. Yeah, you can. The other thing you can do is buy used batteries, the Ryobis, off of eBay and stuff. Buy them for dirt cheap. Take them apart. Typically, at worst, you only have one bad cell in that entire pack, and there's 8 of them in there, I think.
Yep.
That's a great way to get 18650s. The other thing is old laptops. The batteries in the older laptops where they had a removable battery, a lot of those, if they're lithium batteries, they're 18650 lithium ion batteries.
I have very popular cells.
So we'd like to get Mitch just joined us, waiting patiently there. I'd like to get Mitch's intro. So go ahead, Mitch.
Hey, sorry, I'm sick. That's why I didn't join until later. I'm Mitch 3D, or Mitch with Mitch 3D. On Twitter is the Mitch 22. I actually have a background in combat robots as well. I did BattleBots IQ in high school. That's kind of my introduction, and then we have a Dallas area robot combat, and so I've been doing it since like early 2000s. But usually on the smaller scale, the 1 pound and 3 pound combat robots. So, but currently I'm, but that actually, I think combat robots actually got me into 3D printing in a way, because I learned about CNC writing and CNC milling, and I was like, oh, I can make robot parts at home. That's really cool. So, and then realized that that's really messy and loud. So when the 3D printers came out, I was like, oh, we could 3D print robot chassis and gears and wheels and stuff. And I thought that was really cool. So that's why I bought my first MakerBot like 8 years ago. So, but yeah, combat robots has gotten me into kind of this hobby, a side hobby, but now it's my main hobby. But recently I bought a Antweight robot on eBay from a popular robot builder, and so I'm hopefully going to compete that next weekend. But anyway, yeah, that's why I wanted to join, because I heard the topic of robotics, and that's really what got me into 3D printing is robotics.
That's a good story. Yeah, for me, I really wish 3D printing was as popular as it was when I was in Drexel, because as soon as I graduated Drexel, I became employed by Siemens, and I was working there in their R&D for 17 years, and it was in process automation. It wasn't in, I mean, technically it is robotics of a form, because you're automating a process. But I was really more interested in actuators, like linear actuators, making stuff move to do a task, like almost like factory automation, but like even building an autonomous robot. So I designed a lawnmower. It wasn't a novel idea, because there was already robotic lawnmowers at the time, 1994 timeframe, and I had this whole thing designed up, but I could only use like wood, maybe some small aluminum that I could cut with my jigsaw. But man, 3D printing, using Fusion 360, or if you use Tinkercad or Open whatever SCAD, man, it's like you can just do so much now compared to where it was in 1994. And that's why I started the topic of robotics, and rapid prototyping for robotics was the first topic that we talked about this, I think, a month ago, or maybe a month and a half ago. And it's just changing how quickly, and you can get lazy too. Like you're like, oh, okay, I'm just going to print it and see if it works. Instead of spending time sitting there, really looking at your design and seeing, like Dave was talking about, he had to redesign some parts. I'm wondering, Dave, if any of that was done in like Fusion 360, where you put the assembly together and you kind of did some animation to see if the limits, or if it was something that you just discovered that you had to redesign the part and you measured with calipers to see that, okay, I need to make a gap this big, and then you reprinted the part. I mean, that's the advantage of 3D printing, that you can get lazy on the design side and just like, I'll just let it print. The advantage is that the printing part, okay, it takes a long time, but for anybody who, we all know 3D printing, but for those who don't and watching the replay, let's say you're not part of this technology, for 3D printing, you can print a part and you can go to dinner, you can go to sleep, wake up the next morning and see if the part is done. 90% of the time, if you got a decent setup, your print is probably going to be okay. And then you can take a look and see, like, yeah, okay, that was good. The only difference is that you're potentially wasting filament, certainly energy, for the amount of power it takes for the printer itself. But Dave, yeah, tell me about the iterations that you were making and engineering.
Well, when it comes to different ones, is that like Dave Fiero, when he's been doing this one, he's doing it all in SolidWorks, and he is doing full assemblies in SolidWorks. I am an Inventor or Fusion 360 guy, and I really like the idea, and for myself and just the way my brain works, I don't do assemblies. I usually actually design each individual part kind of in my head and then draw it out and print out multiple iterations. I almost always print the part like one shell, 10% infill, just a crummy resolution, you know, 0.25 or 0.38 layer height, and print it out just really sloppily. Put it together and go, yes, that works for me. I have it in my hands and I actually play with it. And then I go, now I'm going to print the real one. And then I go back and actually print the real process or the real parts and out of the actual material I want. So I actually have, you know, cheap filaments that I go and get, you know, just for my crumb printing. And then I actually have my expensive filaments that I use for my final print. And I consider iterations part of the process because rarely do you get it right the first try, even if you're doing assembly work. So I spent a lot of time about that. By the way, it was mentioned earlier, ant weights. If you don't know the term, when you get into combat robotics, we have things like ant weight, beetle weight. You know, then you start getting into, you know, the lightweights and the heavyweights. Those are just the weight classifications. So it's funny is that almost anywhere in this country you can find somebody fighting ant weights and beetle weights, which is 1 pound and 5 pound robots. So anybody that wants to get into the lightweight competitions, those are definitely the place to start. I have this conversation almost on a daily basis with one of our workers because he is heavy into the ant weight and beetle weights. So those are fun places to start that you can build, you know, sub $200 bots to go fight. So it's not a bad place if people want to play with that.
That's awesome. Yeah, I'd love to get into that. I'm just so heavy into doing the YouTube thing and doing the other conventions and stuff. Yeah, I'd love to get into that. I definitely want to build a robot beyond my camera slider. So, Mitch, can you tell us more about your battle bots that you were doing? Anything else you want to add to
that? Yeah. So, really, before 3D printing, most of the stuff I make is my dad had a kind of in his garage. He bought a bunch of Harbor Freight tools, and so we had like the Harbor Freight mill and, you know, lathe and all that. So I was able to make some, you know, make some parts, and I learned about, you know, TIG welding and designing a frame and electronics, and you know, we were using wheelchair motors and, you know, sealed lead acid batteries to make these like robots, and that was back in high school. So and then up until I went to actually, you know, I went to school for robotics, but the programming is what kicked my butt. So I'm not really into the programming side of it. I like the hardware side. But you know, with now the combat robot scene has kind of changed now because, you know, we got crazy powerful LiPo batteries. We got, you know, crazy brushless motors that are super cheap now. So you can get massive, you know, brushless motors, and like just, and also there's actually a lot now done in, you know, you can essentially do offshore manufacturing, small scale, to do robot parts. Like if you need, you know, well, you can do it locally too, but like, you know, people are water jetting, you know, tool steel for their weapon blades and stuff like that. So it's like, you know, the idea that you can have digital manufacturing like available now relatively cheaper than you did like 10 years ago. The combat robot scene has changed a lot. But my personal stuff is my first robot, you know, like 12 years ago, was just a piece of aluminum that I put together. It was like really soft aluminum, so you could bend it by hand and all this stuff, and, you know, a lot of hot glue and duct tape and, you know, all kinds of stuff, and zip ties. And now I do the last robot I made, I used I actually printed it. I designed the whole robot in Tinkercad. It was an ant weight robot. It was like a wedge that looked like this, so it can move, and it was not really effective. But I did the entire thing in Tinkercad, and because I was like refusing to use Fusion 360 for some reason. But yeah, I did an entire robot assembly in Tinkercad, and then I realized the limitations of Tinkercad because having to group and ungroup everything. It's not meant for assemblies. I can guarantee you that. But that was like a year ago or so. But I printed in PETG, and I think I have a video on my channel of it, and it was a crowd favorite because I actually got into the rumble with other robots, and it got hit, and it just shattered. The PETG like shattered everywhere, and there was shrapnel and stuff. But what's funny is that the popsicle stick and the hot glue that I used to kind of glue everything together actually held, and all the motors and the electronics were still held on to like one half of the robot. So half of the robot was still alive, and I was just kind of like sprawling around on the arena floor. So that was a lot of fun. And I won the rumble just because I survived an attack for that. But recently, I know David might know Robert Cohen. His channel is really good. If you have a chance to look at Robert Cohen, he's built one of his robots is called Crippling Depression, which I thought is kind of a funny name, but it's an undercutter, and I think it's a 30-pound class. But he goes into machining. He's sponsored by Tormach, so he actually shows how to use like a Tormach mill and all that stuff. But anyway, actually was the one I bought his Sergeant Cuddles, which he has a whole YouTube series on how he designed Sergeant Cuddles, and he actually does 3D print the chassis and stuff like that. But the final one's actually milled out of Delrin. So ironically, I got into 3D printing because of combat robots, but I probably wouldn't use 3D printing much for combat robots just because it doesn't hold up that well. On the ant weight scale, you can get away with Nylon X. Nylon X is and the Onyx Mark Forged nylons, carbon fiber fill nylons. Those are probably the only thing I would ever use in combat robots at this point, because it's a really harsh environment. It really teaches you really quickly how to engineer for toughness and also for assemblies, because you got, like he said, 20 minutes to fix your bot. You have to make sure that you can, get a threaded insert inside of it, and like make sure you don't strip any threads, or you have to really design it to be easy to maintain or replaceable. So, but yeah, no, I get really excited about combat robots because of this, because it's just a really cool engineering challenge.
I'm gonna cut in here on you real fast.
Yeah.
I have no experience with combat robots. Please don't think that. I don't have a problem with that. I think it's really neat and it's a fun sport to watch. Most of my robotics experiences with working with the astromech.net R2D2 builders group. And I kind of wanted to cut in because so far both of you guys have experience with robots, and both of you are kind of like meh about the programming side of it. Now, the programming is hard. It is, but there is large groups of people out there that are willing to help you with this. Don't let the programming side of this deter you away from robots in any way. And if you're willing to actually learn the programming side of this, you will get massive amounts of experience in this, because people will just start grabbing you off the street to help them with their robots. I learned more in a year just with helping to program R2s than I knew about any robot programming, and you wouldn't believe how much of it transfers over. So don't let the programming scare you if you're really interested in learning something like this. There is large amounts of resource out there, and loads of people that would love to talk to you about it. Trust me.
And I'll jump in on that too, because I'll say this: when it comes to programming, robotics is the easiest and best way to learn it, in all honesty. And the main reason why is because if you've ever tried to write software, the actual output of what you do is relatively boring. I mean, you see a dot move on the screen, no big deal. But when you're programming and you actually write code that moves something, as soon as something slightly moves, it is such a, it feeds you to move to the next step. It feeds you to move on. So if you want to learn programming, robotics is by far the best way to learn it.
Yeah, I would absolutely agree with that. I mean, I've never written any full useful applications. But yeah, playing with Arduinos, and just get an Arduino, get a servo, or get a stepper motor and a driver, and start playing with that. And the first time you make it move, blows Hello World out of the freaking water.
Absolutely. There's a YouTuber, most people know him as his name's Barnacles. He has a robotic arm sitting on his desk. And I was watching a stream that he was doing right after he got this thing, and he programs it, and it reaches down and picks a pencil up off the desk and drops it into a cup. It blew my mind that he was able to do that. And like one of the R2 units that I'm helping somebody work on now is we've got this thing to move 17 feet before it freaks out. But it's mapping the area that's around it with about 7 different cameras, and it's following a beacon that somebody can attach to their belt so that they can walk around at a convention, and this thing just follows them. And the fact that this thing can make it that far just blows my mind.
Yeah, somebody mentioned Lego Mindstorm kits, and they have basically block programming, visual programming, which there's actually like several block programmers, I think, even for Arduinos and stuff, to make it really easy to learn. I think I've used one before, but yeah, that's and also the big thing is like the libraries that are written. From my experience, I'm more of the most I've been able to code is like copying examples and then making it work. So, but yeah, like Adafruit's libraries for servos and stuff like that, like it's makes it super easy. And even sensor feedback. There's the Pixie Cam, which is basically like a self-contained image. It's a camera that has actual image recognition, or it can color tracking and all that stuff. So it actually outputs the position of the object that it wants to track, and so it makes it a lot easier to do, visual inputs and stuff like that. But you can even get LiDAR sensors now really cheap because they're on the robot vacuum cleaners. You can use a cheap LiDAR sensor, and I think there's lots of resources online that I've seen on how to interface with them. So there's way more stuff that we have now than we had 10 years ago, for sure.
Rover in the chat wants to know, he directed the question at Mitch and David, but I mean, if anybody else has any input in it too. The current robots are all radio controlled for like battle bots. He was curious how far you guys think we are from seeing self-determined battle bots or autonomous battle bots instead of radio controlled battle bots. I think that's probably a question a lot of people don't want to answer.
Yeah, the robots are going to take it well, so we don't want to give them sentient. I would say we're kind of far away, because if you've ever seen like an autonomous, like the sumo bots he was mentioning before, they're like super quick and stuff. But when you're learning, I've done sumo bots, and it's basically just like really boring to watch something kind of go try to find the next object, and then it takes forever. But now sumo bots, they're like 5-second matches and they're over.
Can we hear the feedback, anybody?
Yeah, I hear it.
Always feedback. Somebody, can you do a mic check and find out? Okay, Richard.
Well, that's going on. Just wanted to mention that a couple of years ago, I went to an event. There is an international apprentice competition. It happens, I forget if it's every 2 years or something like that, and it's worldwide. And it's apprentices from all sorts of trades, whether it's bricklaying, working with marble, but into electronics. They had a number of robotic competitions taking place. And for the robotics, none of them were they allowed to use remote control. Once you hit the go button, your hands were off. And you got to see some of it was navigating an obstacle course. These robots were, the smaller ones were the size of, a mug. But they went up from there. But it was fascinating to see them go. And yeah, it's a different world, but it's still really neat to watch. Especially the fun part to watch isn't the robot itself, is the teams. Is they're itching to get their hands on it if they see the robot going off to the side while their competitor is over in a different direction. It's quite a challenge, a lot of work to get there, but I think that'll be a fun area to watch. But then, yes, we get into the world of AI issues. I do have another question that I want to jump in here with, and that is, we see BB-8 back there. Last summer, I think it was, Disney went and to the various sites and had STLs pulled of anything Star Wars related. What's happening in that world for those that are into robotic building?
Well, that's a challenge depending on who you talk to, but let's put it this way. There's not a lot of people that just kind of publicly post the files. So a lot of the files are traded just back and forth. You know, they make them free, but a lot of them are kind of traded through forums and knowledge bases because Disney doesn't really want those files out there. Most of these builder clubs have worked out some sort of verbal agreement for the most part to sit there and says, we build them, we keep it good, we refuse to sell anything, and we try to, you know, make it fandom rather than actual hardcore. So I can usually go and talk to someone else that made it and said, where did you get your files? And they'll say, this guy over here and this guy over here. And we'll eventually come down and go, all right, this guy has the right file for me and then the right version that works for it. But yeah, you're not going to find them post the thing first.
Yeah, a lot of it, like with Disney now, I mean, because this topic's going to come up more and more with Disney owning Marvel and owning Star Wars. The fan art thing is sort of, it's walking a really fine line because Disney has to protect the image. Is basically, it's not, I don't think it's necessarily so much about the copyright, it's protecting the image. And you look at Disney, Disney is, for the most part, the better known part of Disney is all family friendly stuff. They have to protect that image. So, I mean, if you create if David takes his BB-8, puts the lighter modification in it, and goes and lights something on fire with it, Disney's not going to be as much of a fan of that at that point. It's protecting that family-friendly image rather than, you know, necessarily copyright. Because the more people see this stuff in person, you know, there's not a lot of people who haven't heard of Star Wars or seen Star Wars. But if David's out somewhere with his BB-8 or his R2-D2 and he's driving it around, somebody's never seen it, they may be curious now that they've seen, you know, this guy's dumped, David, you said some people spend 20 grand on an R2-D2, and I'm sure probably some have gone above and beyond that. Man, what's this movie about? Or what's this action figure about that this person's spending so much time doing? That's what they're really after to protect.
Now, on the flip side is that places like Disney, they actually will, there's a couple of builders that Disney contacts and says, hey, listen, we can't get a BB-8 out here to premiere. Would you please bring your BB-8 out here? And I know a guy that, you know, was flown out. He's been flying out to every single Star Wars, you know, premiere to take his R2 or BB-8. You know, these guys usually show up and do the red carpet premiere. So most of the time you go to a Disney event, you're going to see usually a fan spot out there on the carpet. Disney, because of Star Wars Land, has been hiring a lot of bot builders to build bots that are going to be driving around the theme park down there.
Cool. I know Darren Moser, he's the one who created the full-size K2SO. And there's sort of the same deal as BB-8. There never was an actual K2SO. It was all CGI. I know he's been featured by Disney on their social medias and the Star Wars social medias that they're in control of. I mean, that right there says, you know, hey, we're good with all this fan art stuff. Just treat us nicely.
As long as you make it good, we'll give it to you. We'll let you get away with it.
Right.
I think it was 2 years ago, Make Magazine had a short article on building R2. And one part of that was the builders club that was involved with it were actually able to go and measure the original R2 and get all the measurements right out of the Lucas Museum, I guess it was. So, once again, if you're doing it right, you can work with them or deal with, the drawbacks of being stomped on. But
and sometimes some people sneak stuff out where they're not supposed to, and that becomes part of it.
Can I jump in real quick? Mitch, can you throw in the comments that Robert Cohen, a link to his channel? I've not been successful to find him.
Yeah, let me do that.
Sorry for interrupting. Mitch said he had to go, so I wanted to interrupt and get that in there.
Okay. Yeah, let's see. He has like the most iconic logo too. He also does 3D printing stuff, and I think he's been involved in the community. So here, there, I posted it. He's definitely been he's actually, one of his cool projects on his channel is he took a Stratasys printer and is retrofitting it to be just a regular FDM printer. But I think he actually has a CR10 as well. So it goes to show you that, you can go from a really expensive machine or a CR10, really cheap machine and, get probably pretty similar results.
We were talking about programming. I'll tell you a funny little story. So if you didn't know, Print Installer recently bought MakerBox. And what happened is that Nick, the original owner of MakerBox, he had built a spinning machine. It was an Arduino controlling a stepper motor to spin the filament. And since they technically own that machine, even though it was in my building, I couldn't go and modify it. Well, the very night that we signed the contract to, buy the company, I immediately went in, tore it apart, and changed all the programming on it to put all the features I wanted on that machine. And it wasn't too bad. It was, a couple hundred lines of, Arduino code to actually make that modification. So it was only kind of funny just because of the fact of when you learn that programming and everything like that, you really get this opportunity to customize everything in your house. And all of a sudden you realize how annoying it is to open the fridge. So you'll build a bot just to do that. So
I think that kind of spawned in a new era of obviously Simone Gertz, her crappy robots. Those are really iconic because if you think about it, everybody's been there. Everybody's kind of started with servo controlled robots to solve a task, and not everybody's successful at it, and sometimes it's not even worth it. But and there's a ton of other YouTube channels now too doing similar things. What was the other one? I forgot that. But anyway, he had a talking banana. I'll have to find the link, but yeah. But yeah, useful and useless robots. It's a fun way to learn how the intro to programming and robotics, but then it really can lead to actual robotic projects.
By the way, can we give a shout out for Simone? Hope her a speedy recovery on everything.
Definitely.
Yeah, for sure.
Yeah. Has anybody heard anything? I haven't.
Well, the best news we heard was shortly after her recovery, she cracked a dirty, inappropriate joke or something. So
that's awesome.
That's what her doctor said or something.
That's funny.
Which, by the way, if you haven't watched any of her videos, I'm going to suggest people do, because I love her approach to how to do robotics. It's not intimidating. It's not somebody sitting there saying, I built this and it's impossible. You'll never be able to recreate it. The things that she does is obtainable for people that are trying to learn. It's a really well-structured show by her. So I give kudos to her for coming up with an actual educational robotics show.
Her TED Talk was amazing. It really gave the mindset of why creating shitty robots is awesome.
Yeah, she was very good on that. Back to your robots doing meaningless tasks. I have a dog. I've been trying to train my dog to go into the other room to pick up a can of soda and bring it to me. And my wife picks on me because it's taking me forever. She's like, just program the robot to do it.
My last meaningless task was previous house before this one, I had a doggy door installed. And what I did is there's always a hard, security door for it, is I set up a little, Raspberry Pi to control that to open and close. And then I put a microphone on the inside, and I could actually call my dog inside the house and lock her inside the house, and then tell the guy that's mowing the lawn that now he can go mow the backyard while I was at work. And it was the lamest programming in the world, worked like a charm. Everybody loved it. And that's meaningless, robotics in a nutshell.
At Murph, I forgot the guy's name, but he had like animatronic, the Tiki. But I made something similar.
Jim Scuba.
Okay. Yeah. That's pretty amazing. And that's not like really complex programming, but it with the animatronics, it looks cool. Like the whole idea is that it looks natural. So I made like a simple. It's on my Thingiverse page, but essentially a third eye for costume, and it was just a micro servo with a random movement, kind of like Matt's like robot head. It just had random movement, eye movement. So, and that was just a simple program with an Arduino. I think it was like $20 worth of parts total, and and I did it in Tinkercad. And it took me maybe a couple hours to actually design, and then a couple hours to build it. But you can do the simplest thing, and it has the most dramatic effect, right? Especially with cosplay, because that's the whole point. But with robots, it's true. It's like you can really just do like one degree of freedom, like actuation, and do something useful. So it's not, you don't have to have a complex 6-degree freedom arm just to do one task. You can always do it with like more specific application.
By the way, for Mitch, the best, if you ever want to see a combat robot guys fight, tell them that combat robots aren't real robots because they're radio controlled. That will start a fight real quick, by the way. So I would say, in all honesty, just for people to understand, robotics doesn't necessarily mean it has intelligence or it does something automatically. Robotics, I think, is a mechanically driven device. So you can use it any way you want, but a mechanically driven device is a robotics. It doesn't have to have a bunch of AI. However, as soon as you add AI, it becomes cool robotics.
There are some automation too. There's automation in some battle bots as well. So like automatic tracking and stuff like that, and they use accelerometers and feedback systems sometimes, but it's not entirely remote control.
Just to step back real quick, Mitch had mentioned Murph, the guy who had the animatronics, Jim Scuba. I threw a link to his YouTube channel in the chat. He's actually doing a series on. He had tikis, the tikis from the Disney Enchanted Tiki Room that no longer exists. He did those. He's doing a tutorial, on how he did those animatronics on there. And basically, it's a really simple system. He's using servos on a finger puppet, essentially, to record the positions on an Arduino. And then once he's done, he presses a button. And from that point forward, every time the Arduino powers up, it resteps those until he again presses a certain number of button presses, and it allows him to again reprogram it. So like when you see his setup at 3D printing events and elsewhere and on YouTube, everything he does, he basically choreographs to the music or whatever it's doing. So sorry, I just wanted to throw that in there to fill in a little bit of information. But his link's in the chat there.
Thank you for posting that. Yeah.
I don't know if it's still out there, but I used to use a programming language called Access. It's not Microsoft Access Data Management, but it's Access, and it was a controller language that we use for museums and boardrooms to program objects in there. And that's one that could take in inputs, for example, a light beam being broken or just someone opening a door, what have you. And then it would automatically go through, do things. My favorite work with it was for boardrooms where the CEO could go and play a video during a meeting and not screw up, because once he hit the video button, the system would check to make sure the curtains were closed, the lights were down, there's actual video there, the projector was on. But key thing about it was the way it looked at time, and dealing with time was a big issue with the robotics, because most programming languages, things are sequential. You're going to do this, and then this, and then this. With the Access language, you had time zero. And from time zero, you could have multiple activities going. And everything was based on that time. So it did make some programming very easy. And when I made the move over to something like, well, when we're playing with the Lego Mindstorms, it took a while for me to get back in the headspace that, no, this has to happen before you can go on to that, before you can go on to that. And you have to put all these steps together for the timing, so all the timing works out. So, you know, just two different looks of dealing with the programming. But it was mentioned that, yes, it's robotics. If it's mechanical and it moves on its own, that's one aspect to it. But you do hear about the battles with combat robots, and I've had this myself. And yes, it's like the Mac versus PC. Is it robotics or is it radio control events? But you get the control. You have language for both of them. You have to deal with the signal, and you have to understand the physics behind whatever you're moving, so that your code is going to work with it, and the fact that the stuff that you've printed is going to come together and will actually do what the programmer wants to do. And it's, you go back and forth, you have to think about it both. Timing is the issue, but as was mentioned earlier before, when it works, it's mind-blowing.
Yeah, I think you could go with the robotics. The Rossum's Universal Robots was kind of where it first mentioned. They're basically like robots as slaves, essentially, or servants. You know, they do a task for you. So you can kind of consider anything the automation robotics in a way. But if you read Asimov too, there's some interesting, stuff about robotics that Asimov wrote. But if you want to get into the history of robotics, but yeah, even automata, or I think is that how you say it, automata. Just like cranking a thing to have some kind of, animation happen, like that could be a very simple form of, robotics. So, yeah,
if you get into the history of it, it's quite amazing what they used to do, 150 years ago. And now we're just adding the electronics to it. But yes, the 3 laws of robotics. Let's see if we can program that into it.
Another name drop is for people that want to start is look at Scratch programming. That's probably a really good starting point because they have a lot of robotics packages in there, and it's a visual programming language, so you can learn a lot just from starting there. Yeah, it's a free program, so go out there and get Scratch, and you can get started pretty quick to kind of learn some stuff with it. So that'd be my suggestion for people. If they want to go slightly beyond Arduino, or even if Arduino intimidates them, I'd probably start there to learn a few things.
Yeah, to answer your question earlier, Richard, yeah, I know about the access control language, or ACL. Now it is still being used, but people are moving more towards ACML, I think is what it is, Extensible Access Control Markup Language. It fixes most of the time control problems that the first side had, but it works generally the same. And there are people that do use a little bit of it in all different kinds of movements, not just security and sound and stuff.
I posted a link to Scratch. Can you verify that that's the correct language, David?
While David's double checking that, John, I know we're getting close to the. We started a little bit late, but we're getting close to that 2-hour mark.
That's fine.
If you wanted to do outros, I had a question to pose to everybody to answer while they're doing their outros. That's all right with you?
Yeah. So we can start the outros now. Is that what you're saying?
Yeah, if you don't mind.
Yeah.
So the question I wanted to ask everybody as they do their outros is, so we're talking robotics. As you do your outro, pick something kind of quick off the top of your head. If you had no limitations with robotics, what's a project that you would want to do? Something you'd want to build with no limitations on robotics, on components, on skills, whatever. The second part of that question, if you don't have an answer for that, is what's something that would interest you to get you into robotics and combining your 3D printing with robotics?
Can you type those questions in chat? That'll help for us to refer back to.
Oh, sure. I got to put that in words, in letters.
You have to re-remember what you said.
Okay, well, go ahead.
I'm going to start from my left, and so that's going to be David. David, so this the way it is, it's almost like roll call. We're going to say who we are, where we can find you, what you do. We already learned everything about you, but you can summarize quickly. And by the way, I still want to know more because I know you do a shit ton of stuff, and I'd love to have you back on in some form, even if it's not 3D printing, because you're just an amazing dude. So it's all you, David. Tell us how to find you, what you do, where you are.
So, well, a quick outro. I'm David Randolph. I'm one of the owners of PrintedSolid.com. And best way to find me is PrintedSolid.com. We have all our social media accounts down there, and that's the best way to kind of track me down. And so I would say that, and then I don't know if you're going to come back around for those questions, but I have a couple interesting responses for that.
No, if nobody has to go, you can go with those responses.
So if I could build anything that, robotics-wise, and it's something that's been bouncing in the back of my head, I really want to develop my own 5-axis CNC machine from the ground up. That's in my radar, and that's what I want to work on. I've built a ton of routers and plasma cutters and laser cutters and everything else and 3D printers, of course, but everything else from scratch. I just have not gotten my head wrapped around the mechanics of a good 5-axis mill and how I'm going to program that. So that's my dream project.
Have you seen 5-axes?
I've seen 5-axes. I know how to program G-code for them, but building my own and actually doing that's firmware is what I really want to kind of master. And there's just not enough open source of 5-axes yet out there to work with.
Did you see? You saw them at New York Maker Faire, right?
Oh yeah. Trust me. Every sub $100,000 5-axis machine I have drooled over and dreamed and considered, selling my house to buy one.
You don't have a Pocket NC? A Pocket NC, maybe?
I have looked at the Pocket NC. $5,000 is a decent price for that. The problem is that I don't think their language is, or their software is mature enough to consider widely acceptable yet. So if I did, I'd want to be the guy that did the software. My dream is to be the guy that actually made 5-axis CAM software usable for most normal humans.
You have a lot of money if you did that. Because
in a heartbeat.
Even our big in CNC industry, like 5-axis is still really difficult.
By the way, if anybody doesn't know, when we say CAM, we're talking about the the language. So it's pretty much CAM is the machinist version of a slicer. And when you're dealing with 5-axis, just you have to worry about the actual mechanics of the machine more than just making material, because your machine itself can actually crash into your workpiece. So CAM software gets really complicated at 5-axis.
Yeah, that's for sure. All right. So, Mitch, do you have to go? You indicated that earlier. Do you want to go next?
Yeah, sorry, I have kind of a head cold, I guess. All the traveling I'm doing.
Then we'll go to Draco.
Okay.
So good. You can go, Mitch.
Okay. I'm Mitch. Mitch 3D is my YouTube channel. I haven't really updated lately, but I'm on Twitter at the Mitch 22 and Instagram and all the other social media under the Mitch 22 or Mitch 3D. So, yeah. So I think if I had no limitations, I'm gonna make like cheesy answers, but either I don't think it's really robotics, but a room-sized 3D printer that I could print a car would be really cool. But back in kind of college, I wanted to build. I wanted to my idea for my senior thesis. I never got to it, unfortunately. Was to have a 3D printer and like basically a desktop manufacturing. So having the fabrication of the parts, so 3D printing, and then a robot arm that would actually be able to take the part off after it's done and then do all the assembly, like drop in a PCB that's been, prefabricated and then, put in the screws and all that stuff. So basically automated, like a at-home automation fabrication lab, like that does, does the assembly for you. It's probably not practical really because it's, who needs to really manufacture at home, but it would be, I think that's something that would be cool in the future is to have the idea that you could have basically a fully automated manufacturing system in like a room, anyway, that's I like industrial automation stuff. So I think that would be my goal if I had the money, and no limitations, but yeah, that's also kind of gets me into 3D printing is that you could use that 3D printer as one of the steps in the fabrication process, and fully automate it. So,
Very good.
We really can't believe that's impractical because that would be amazing to put file in one end, epic thing pop out other. That would be great.
Yeah, and you could, yeah, exactly. And you could have your Eagle file, have the PCB milled. You could have it populated with a pick and place. You could have a 3D printer to make the casing. You could have, CNC plasma cutter to make the metal bracket. And you could, you still have a human element to this, obviously. But yeah, the idea you can go like direct digital manufacturing from CAD directly to a part with a black box, essentially, we'd call it. It's a black box manufacturing. Anyway, I think that's kind of exciting that we're almost there.
Yeah. All right. Thank you, Mitch. I'm going to go next from my left. That'll be Draco. So go ahead, Geek Tech.
Well, like I said before, I'm Geek Tech. My channel's it's Geek Tech all the way around. YouTube, Twitter, Twitch. I'm on all of it by the same name. Not to make it easy, it's because I'm lazy. But no, to answer your question, I'm gonna have to. I'm not gonna think that my thoughts are impractical because I'm a dreamer, and that's kind of the maker motto. We dream it up, and we either dream it up long enough, and then we turn it into a reality, because that's just what we do. But if I had no limitations, I would reach my goal, and my goal is I'm going to put a robot in every home. It's 2018. Let's be honest. We should have had robots in every home by now. I think. I'm not saying I want full-fledged Jetson Rosie making my breakfast every day, but we really need to push this forward. I think that there should be robots in every home. Yes, there are human things that still need to be done, but I think it would just be cool to walk in and have a functioning, thinking, job doing R2 sitting in your kitchen. just hanging out. I mean, I think that'd be great. And I mean, that is my goal. I mean, it's not really based on no limitations. I'm gonna do it. But I mean, to get me more interested in robots, I mean, I try to learn as much as I can. Every year they do a big DARPA thing on TV and on social media and stuff like it, and you get to see the advancements that they're getting with robots. You see all kinds of stuff, and I mean, I would love to go to one of these events. I would love to be more active and involved with robotics personally, and I want to see more of the 3D implication into it. This 3D printed BB-8 behind him here is amazing. Just looking at the gyro build that he's got sitting right behind him is just beautiful work. And just to know exactly how much of that is 3D printed is amazing, because you're talking about the time that it takes to do it and the materials that it takes to do it. And he could build it out of steel and have these massive, humongous machines to do this job for him, but he's doing it out of 3D printing. That's amazing to me. All right, if that's not advancement, I don't know what is.
That's like, you got a lot of energy, man. This topic is really exciting. I could talk for this all night. We're going to end it at around 1 o'clock, just so you all know.
By the way, have you noticed that there's actually full 3D printed R2D2s out there now, even with the 232 conversion?
Yes, I have. Actually, I've holy shit. My next robot is actually I just got most of the STL files from astromech.net. And they're going to be some of the first things I'm going to be printing out on this new machine, and my new one's going to be completely 3D printed.
I'm retiring my styrene one. I'm going to start the 3D printed one.
Well, if you need any help, you let me know. All right, I'll gladly help you out.
Absolutely.
All right, so we're going to continue. Matt, you're next up.
Did you get it, Richard?
Richard, you are next up.
Okay, quickly pass the hat, as it were. Had to get the hat back on. Name's Richard. The channel is Zidim. Easiest way to find things is go to the website, zidim.com, and it links to all the various things that I do. Focus is on 3D printing for model trains, and that leads me to what I want. I'm not looking for the big room size things or anything else. As I mentioned before, what I want is that third arm, something that I could have on the bench, have some very basic voice control, so I can have it hold whatever it is I'm working on and say, rotate left, tilt down, move forward, what have you, and actually move the parts, so my two hands can actually wrap the cables or do the painting, what have you. And as I was looking at my workbench to talk about that, I realized that the other thing you can put on that is one of these webcams. So it can do the tilt down and move into the area I'm working, because it's always a challenge. I got 5 cameras set up in this room, so trying to move everything around. If I could have that arm under voice control, moving things around, I'm there. I got what I want. And yeah, it's exciting stuff that a lot of these things I wouldn't even have thought about really getting involved with a few years ago, but with 3D printing coming along and giving you the power to do things, that opens up a whole world. And it's just not me. When I see little kids, there is a mobile maker van that is stopped in town a couple of times, and they have 6 3D printers in there, but also they have a lot of other equipment in there, and kids start to play with some robotics. They start to play with their ideas, memory wire projects in there, and I'm really excited to see what they're going to be creating as they grow up with these tools, so they can make it, and they can see BB-8 and they go, I want to make that myself. But getting that skill, what are they going to make when they move beyond that? I think we're going to see a lot of neat stuff there. And people think about robotics being rather rare and still in industrial areas. It was pointed out a couple of months ago, that I think it was in Japan, one of the ministers was talking about it. He says, Japan is the leading manufacturer of robotics. However, they're not in people's homes. There are millions of robots in people's homes today. People don't think about it, but they have the Roombas and the various versions on that, the ones that wash the floors, not just the vacuums, what have you. And his point on that was none of them were made in Japan. And he was quite annoyed at the industry in Japan for shooting way up high when people want some practical things in their house doing things. And yeah, I'd love to have a robot looking after my cats sometime, chase them around the house and clean up after them. But I think, you know, we're just on the edge of getting to the point where, yes, we can talk to the house and say, you know, here, make me supper and let me know when it's ready. You know, we're getting closer to that.
Yeah, that's cool stuff. Scary.
And did anybody do the modeling on the hat? I know last episode, Matt put out a challenge. I don't know if we got any results in.
Oh, that's a good point. Yeah, for anybody who didn't catch the last stream, there was a challenge put out for somebody who's good with 3D modeling and more so the organic nature of 3D modeling to model Richard's hat with the key and everything on it. I don't know if I haven't seen anything on Twitter or Facebook about anybody doing it, but that's a good point, Richard. I actually forgot about that. Challenge still stands.
All right, Matt, you're up.
Hey, everybody, I'm Matt from How I Do It. Real quick to answer the questions that I posed to the panel tonight. If I had no limitations on robotics and skill set, the one thing that I would want to build, which Draco touched on, I couldn't believe you jumped to it. You used my exact example. I want a Rosie the robot from Jetsons. I mean, if you think about what Rosie was to us as kids when we were watching the Jetsons, she could do anything around the house. Cleaning, cooking, basically kind of a general assistant robot. That's what my dream thing would be that I'd build if I had unlimited hardware and skill set to be able to do it. So I know like everybody's kind of, you know, these cool tools that you could build and arms that would sit on a desk or maybe even be slightly modular or mobile that can move around to where you need it for whether it's holding tools, using tools, moving cameras around for those of us who do YouTube. Like that stuff would be awesome, but like this would be my one dream thing is to have something. Honestly, I'm looking at my desk and what you can see here looks clean, but that's intentional. Beyond this point, you don't want to see it. It'd just be awesome to have something that keeps after me. I clean my office out about once a month, go through and clean it up, and about a week later, I look at it and go, the hell did I just do? So that would be my one dream thing. But aside from that, as far as the Friday night 3D printing community hangouts, I'm going to post the link again in the chat to the YouTube channel for the Friday night 3D printing community hangout YouTube channel. Go ahead, if you get a chance, go over and subscribe to that channel. There's a pretty good possibility that we're going to be moving the streams to that channel in the future to make them easier to find for a broader audience that is not on Twitter, not on YouTube. Chris Riley, you got the YouTube part, but not Twitter. So make sure you jump over there and subscribe. That's interesting. Nightbot hid that message. The other thing is June 22nd, 23rd, and 24th, more specifically 23rd and 24th, in Bel Air, Maryland. There's going to be the East Coast Rep Rap Festival. I know you do it. John's going to be there with a table set up. Martin from 3D Printing Iceland is coming to town. Kat is coming from Liechtenstein. She's going to be there. Country 3D in the chat's going to be there. Let's see. Vicky, T-Gall 3D. She's going to be there. Chris in the chat is going to be there. He's actually one of the ones putting on Earth, organizing it. There's going to be a bunch of us who are regulars in the chat, regulars on the stream as co-hosts that are all going to be at Earth. If you guys see us there, be sure to come introduce yourselves to us. Some of us aren't necessarily people, publicly, yeah. Well, some I know describe it as introverted. But if you see us, come introduce yourselves. We'd love to meet you guys. We do have the Friday Night 3D Printing Community Hangout has a community build currently going on. There are pieces available to do a 4-foot by 6.5 foot version of the logo. Right here is actually the XYZ coordinates of all the parts for the community build. We're currently somewhere right around 55 to 60% of the parts claimed. If you're interested in printing a part, email f3dpch@gmail.com. f3dpch@gmail.com. Sorry. That's in the chat. Send an email, say, hey, I want a part to print. All the parts are 125 millimeters by 125 millimeters by 50 millimeters tall. So most any printer can print them, but we do have some smaller pieces for people with really small printers or that are on a tight time constraint because of other printing projects they're doing for Earth or for something else for that matter. So if you have a requirement like that, please include that in your email and I'll make sure that you get one of the smaller, quicker to print pieces. The prints do not need to be in the colors of the logo. As a hint of a contest that's going to be associated with it, creativity is encouraged in your pieces. And when you email f3dpch@gmail.com, you'll get a list of instructions for recommended print settings and what to do once you print your piece. So send an email if you're interested. There are a total of 4 contests, 2 of which are sponsored by Matt Gordon and Dave Randolph from Printed Solid. That will get each one of those contests will get you 1 free spool of the daily PLA from Printed Solid, their house brand, and which is also new to the market. The other 3, 2 contests and 1 giveaway are sponsored by Protopasta. Each one of those, the prize is going to be a $50 in-store, online store, credit towards a purchase of any of their products on their online store. So in order to be entered in everything except for the giveaway, you must print a part and mail it in by June 18th. That's the deadline to get them in the mail so that they get to me in time for us to know if we need to print any additional parts last minute for Earth. The assembly of the logo will take place on Saturday morning, starting probably about 2 hours into the day on Saturday. So get in touch with me to get a part and get more details on those parts. With that said, I'd just like to thank everybody tonight and thank John for hosting.
Yeah, that's awesome, Matt. Thanks for all that. That's
sorry, I was kind of long-winded.
No, it's all good. I saw Dave yawning though during your talk. If that's any indication, just kidding. I've been yawning too.
Hey, at least he didn't fall out of his chair.
So I'm John of How I Do It. No, I'm John of You Do It. You can find my channel. Can you find my channel? Oh, yeah, this is my channel. So you can find me on Instagram, you.do.it, Twitter, you_do_it. So you know, we crack jokes and everything with Chris Riley, you know, about not being on Twitter. But in all seriousness, you know, if you don't have an aversion to being on Twitter, it's strongly suggested, only because there's so much opportunity, so much communication for making things happen. You know, you got the Facebook, you got things like that, but Twitter is where it's at. Twitter is not dead by any stretch of the imagination. There's a lot that's happening in DMs. You know, we crack jokes and stuff all the time, but, you know, for collaboration, for sharing information. So if you're really not on Twitter, consider getting on Twitter. It's not pressure. You know, we're just kidding around, but it comes from the heart that we want you on Twitter if you're not, because you could be part of this awesome community. We really support each other there, and there's some bad stuff that happens, but you can shield yourself from that if you set up your Twitter properly. And anyway, what do I do? So I got involved in 3D printing a year ago. I've been a maker forever. I think I started like at age 2 or something. My dad had me using the bandsaw at age 3 or 5 or something. I forget. Maybe it was 5. And he taught me pretty much everything I knew at that early age. And then from there, I just kept going. And I made a lot of mistakes along the way and broke a lot of things that my dad owned. And that reminds me of who is the space guy, Neil Tyson deGrasse, right? Am I saying his name right?
Neil deGrasse Tyson.
Yeah, thank you. He did a talk, or it was a speech. I don't think it was a TED talk, but it was just something. It was like, let your kids make mistakes. Like and I'm guilty of this. Like I would yell at my son for making noise, and he said that that's an experiment. Your kid was just making an experiment with sound. You know, like they broke a glass. Okay, yeah, you can get cut, but that's an experiment in physics. You're learning gravity. It's an experiment in material properties. You just learned that something can physically shatter. Taking things apart. Like I took my dad's stereo apart. I think I would go apeshit if my son did that. So it's like he's like, take the step back and think of it from the other way, that you're so that's Johnny, the step right there. So, you know, you take the step back and let them make the mistakes, you know, do the things, and they're going to learn on their own. And it's a lesson for a lifetime. So I don't think you need to hear from me anymore, because we have an awesome panel. We typically end at the 3-hour mark, so we would end probably around 1 o'clock. Sometimes we end earlier if we have nothing to say. There's a shit ton to talk about with robotics, so we can keep talking robotics. So Dave, do you have anything else to add? I know you could probably talk forever. And we don't mind hearing you, because you got some incredible stories. So good.
No, I mean, the biggest thing is I've always sat there and I tell everyone every time I get a chance, you know, break something, fix something, build it again. I mean, that's the biggest thing for anyone. So you want to learn robotics, you want to learn electronics, you want to learn 3D printing, break it, fix it, build it again every time.
Yeah, that's something that, you know, like we talked about the iterations earlier. So whether you do something in assemblies, like so your partner Dave was doing in the design of that, he did the assembly, the full assembly in SolidWorks, whereas you took a different approach. You modeled each piece independently. I like that approach. I like the approach of modeling each piece independently. But it's more because I don't want to take the time to try to get everything in there, and spending the time designing it perfectly. So is that laziness? Yeah, it could be. But do I want to get there? Yes, but I'm not there yet. So I take the alternate approach, which is iterative approach.
There's
Anyone have
also
anything
something about being in the real world. I mean, when you print it and you try to assemble it in the real world, you learn a lot more than trying to assemble it in software. That's how I learn.
And I agree with that, because you can do. There's always the fight between engineers and whoever's in the field, right? Always that fight. So you have somebody like an engineer who's designing a building or doing electrical layout and stuff, and then they get in the field and the stuff don't work, and they're always cursing back at the engineers because they didn't do their job right. And it's true, because what looks fine here, when you get out in the field, it's not necessarily the same. And I know the same thing happens in the physical world with designing parts. So,
as a person who works in the field on stuff that engineers design and repairs it, yeah, engineers, everything looks great on paper. It not very practical.
it gets you started, right? So the paper thing gets you started, right? So we can't go without it, because if you don't have it, what's going to happen? There'll be chaos. So
absolutely,
it kind of gives it some control, but there is that always that fighting going on.
You can usually tell an engineer is messed up if you try to replace the water pump on a Scion XD 2008 and realize you have to pull the whole engine out of the car just to do it. The engineer didn't think about that.
Oh man.
For a $30 part, and that's pretty common with any car out there, and that's the thing. So if you rely too heavily on software to design it before you actually print it and expect it to come out perfect, you forgot something. You forgot a screw. I mean, the BB-8, most of the iterations of it is not because there was a design flaw, as they realized I can't actually screw that in, because now it's over here and there's no room to get a screwdriver in there, and they forget that. So there's something physically nice about having it in hand. And that's where 3D printing has the greatest value, is even if you're going to make it out of metal, 3D print it first, because you can make sure it's actually going to work.
All right, so this is we could keep talking about this, but we're kind of running out of steam with this topic right now. So let's open up to other topics. Typically after the 2-hour mark, we'll open it up to talk about anything. So it's a free-for-all. So anybody have anything that you're passionate about, or you want to just get out of the way? Maybe you have something that is upcoming that you're really interested in, some project you're working on?
Well, a lot of the projects I've been working on, I can't talk about. I wish I could, because there's I some cool stuff going on out there. But
you could talk. We won't tell anybody.
I know, right?
It's 2 hours in. Nobody pays attention to this part.
Nobody's really watching. But for myself, I mean, the coolest thing is that when I came up here for Printed Solid, I got to rebuild all the laser cutters, which is my favorite, because we needed to get fast, and I needed, and I'm used to building my machines from scratch, and it was a lot of fun because we needed a fast way to do it. So I lazily bought really crappy laser cutters from China, and then tore out all the electronics, all the motors, and the entire gantry, and used it just because of the frame. And it was faster than me building a frame, and cheaper than building the frame. So when you throw away 90% of the machine because it was cheaper just to get that last 10%, that was a lot of fun. And I have a worker there now that I'm trying to teach him that same thing. So I've thrown him a couple of laser cutters and said, rebuild this, and I'm not going to tell you how to do it. And I sit there and watch him figure it out, and I cringe every single time, because I'm like, I really want to help him and speed him along, but I realize I have to kind of sit back and let him slowly do it. I've always considered that the figure it out training model, where you just sit there and you tell someone, you know what, figure it out. You'll learn more by screwing up twice. And that's what I've been working on. And I just got a new 5-foot by 10-foot ShopBot router, which I'm having a lot of fun with. I have absolutely no idea what I'm going to do with it yet, but I found it in a garage in southern Delaware. and had to pick it up and bring it to the shop. So I've been getting that up and running and having a lot of fun playing with that toy.
That's a big surface. You could easily throw a 4x8 sheet on there.
That's exactly its purpose. I'm hoping that I can, do some good manufacturing of parts on it, but for the value I got it for, it was totally worth renting the U-Haul and driving it, all the way up and back and getting 4 guys to lift it off the back of the truck. It was a lot of fun. So that's my latest CNC router, which, by the way, if we're on robotics, just as a side subject, besides 3D printing, micro manufacturing is coming to the home a lot faster than we thought. Earlier, they mentioned the Pocket, CNC, which is a 5-axis mill for the home. You got people like the Shapeokos and the Inventable X-Carves to get CNC routers at home. You've got Glowforge and Muse for laser cutters. We're seeing a lot of these industrial machines coming into the house for manufacturing. KiCad is coming up for a lot of PCB design software, and getting PCBs at home is actually starting to become a thing. So it's not getting too hard for people to actually make whatever they want in their house, no matter the material or any type of manufacturing technique. So I'm really excited by all of that.
Yeah, it's an awesome time to be a maker. All the tools that we have access to, with us doing our yard sale this weekend and me having our Etsy stuff set up at the yard sale, 3D printer out running. I get to talk to a lot of people, old and young, that machinists and stuff that come by and just stand around and talk. A lot of what I end up doing isn't selling the products that we make. It's just talking to people about the things that they used to have to do. Just the 3D printer alone, I can do so much easier than all the steps they used to have to go through. I was just talking to somebody today. She thought that I was printing these, actually. I was printing these, which are silhouette things. They have tea light candle holders. I just designed these last night, actually, for our yard sale. And the lady that I was talking to thought, I took a big block of material and that the printer was removing that material to do it, and started talking to her about, like with 3D printing, you can make something with an empty space in it and even pause the print, put something in it, and continue printing. That's something you never could do with subtractive manufacturing before. Or I shouldn't say before, you still can't do it with subtractive manufacturing. It is, and the fact that these tools are coming into our houses. All of us on the panel here have 3D printers, which are awesome, but getting the CNCs, the 5-axis tools, it's awesome that this stuff's getting to be in an affordable price that almost anybody can purchase a lot of this stuff. With that discussion a little bit, Dave, I kind of had a question more directed towards you. We've been talking the last few streams because I know Fun King 3D is working on printing all the parts for the MP CNC, the mostly printed CNC. What's your thoughts on that project, as far as you have the experience with the lasers and CNC mills? What's your thoughts on the MP CNC as far as usability of it versus one of these thousands of dollar CNCs that you'd buy?
I love the mostly printed CNC. I've looked at those files. I've looked at that design. I've looked at that machine. And in all honesty, I have a hard time upselling someone from that versus like an X-Carve or a Shapeoko. I have a real hard time with it. It's actually pretty decent. It's not overly precise, but it's pretty darn decent. And for people that are used to FDM precision, as far as 3D printing is, I think the MP CNC is amazing. It's perfect for that. It's not necessarily good for a laser cutter right now, but putting laser engravers on 3D printers is just as good as my $8,000 machine is for engraving, just not cutting thick materials. And building laser cutters is surprisingly cheap these days, because if you build your own laser cutter, you can use the same, Arduino Mega 2560 and stepper drivers from your 3D printer to control that. It's not far off. I mean, most of these machines work off standard XY gantries. So all you gotta do is put whatever tool head you want on it. A fun story is back in the combat robot days when I was building one of my bots, I wanted to get a company to CNC plasma a plate for me. And they wanted to charge me $6,000 to cut this one plate. I screamed an expletive over the phone at them and said, no, I am not paying that, and hung up. And I made it my personal goal to build a plasma cutter. And as I started drawing it up, I only needed a plasma cutter about 2 foot by 2 foot, tiny little machine. And by the time I was done, it was a 5 foot by 5 foot machine with a water bed on it, an adjustable plasma cutter with my own controller. And I still spent $3,000 building it, including buying the plasma cutter. So it still costs less than them cutting that one part.
That's crazy. That's a good story.
So I mean, I got a couple write-ups in Make Magazine, and Hackaday did it for that reason. And that was a lot of fun. The laser cutter that actually, I always liked having the little 1 foot by 1 foot laser cutter in my basement, and that's how most hobbyists are. But as I started making more and more of these enclosures, I needed a bigger one. And I was living in DC at the time, and the problem is that I couldn't get a bigger one into my house because it wouldn't fit through my door. So instead of just buying the machine because I was in a hurry, I built one from scratch because I could bring the parts in individually into the house and put it together. The only thing that sucked is when I moved out, I had to take the whole thing apart. So that was the only reason why I had to build that entire one from scratch.
Yeah, I've been toying with the idea of building a laser cutter. I do a lot of work with extruded aluminum. Like the printer that I'm getting ready to build is 2020 extruded aluminum for the whole entire frame for it. I mean, it's decent stuff. So I mean, I'm debating on doing a 2 foot by 1 foot laser printer. Just something small. I don't need anything big or anything like that. But my daughter wants me to do a lot of different things for her. And I mean, as soon as you find one thing to use a laser cutter for, there's a million more things you can find to do with it. And then speaking from experience, I had access to one for about 4 months because a buddy of mine had one and he left it at my house. And every time I'd pass by something that I needed cut or something, just throw it in the laser cutter, it'll be fine. I mean, laser cutting is just like 3D printing. It's just like owning a CNC machine. You start off looking at these things going, oh, I'd love to have this. It'd be really cool to have it. I can think of stuff to do. What you don't realize is that once you have access to these things, you will find stuff to do. I mean, it is outright, it's going to happen. They say that being a maker is based on the tools you have access to, and which is very true. But being a maker will get you access to those tools. If you're willing to look for people with access, the people to tools, they'll help you out. So
I'll say this about laser cutters. Laser cutters, in my opinion, since I've built every machine out there for the most part, they are easier to build than a 3D printer. So, the only difference is that they are also more likely to burn your house down. So you just have to be a little more careful. But they are easier to build than a 3D printer by far.
Yeah. Oh yeah, I definitely want to make one. I think that is definitely going to be a project I'm gonna do. I'm still not entirely sure about the extruded aluminum for the frame for it yet, but I don't know. I'm gonna toy with the idea for a bit.
Yeah, hit me up because I've done some V-rail extruded aluminum, and I did an entire body out of extruded aluminum, and it's surprisingly easy. Laser cutters, that's great for. CNC mills, not so much.
Yeah, they don't have the weight that they need. A CNC machine really moves, and those tools are really heavy. Extruded aluminum is extremely light. So yeah,
3D printing and laser cutting, I like to say they don't have resistive heads. Its actual head doesn't have any resistance against it. You have to fight. So they're really easy to build. Plasma cutter, same thing, by the way. The plasma cutter is easier than a laser cutter to build. There's no optics.
Okay. Yeah. All right. Yeah, I mean, I've thought about the idea of plasma cutting and stuff like that, but that's just because, like every decent nerd out there, I want Tony Stark's Iron Man suit in my office. I want actual metal Halo armor. All right, and that would be great to do that with. I've already drawn up the plans, but I'm having a hard enough time talking to wife into letting me build a laser cutter, more or less a plasma cutter that will definitely burn the house down.
By the way, to know about makers and stuff, can I get on a quick soapbox about makers? Way back in the day, and this is World War II, when the guys were coming home and they were all getting houses. Those guys they would come in and they fix their own houses. Everything in their house was fixable and DIY and everything like that. And after that, and all those people came through, that kind of went away. We went to this kind of culture of, no, we have someone else make it for us, someone else do it for us, and we were just consuming it. And I really love that over like the last 10 years, this maker culture that's coming back. The idea that there are people out there that don't want to buy their stuff, they want to make it themselves. It's getting back to that mentality, and I really think that that's a positive attribute for us.
Well, there's a lot of makers out there, and I'm a big supporter of maker everything. I really am. And there's a new maker movement that's coming out now, and I'm debating on how I feel about it. It's pushing people towards local shops to get your materials and stuff like that to help the area grow and stuff, which is really nice. Yes, I agree. Harbor Freight has all these tools for really cheap prices. That's understandable. But you're talking about building a community. We're makers. We build things. It kind of goes hand in hand. It really does. And there's a true value right down the street from me. And I do not have a big YouTube channel. It's thankfully today I'm up to 179. I called these guys about tools I needed for this printer that I was doing. I told them, I said, I'm a local guy. I run a YouTube channel. I need this stuff for the channel. These guys called me back in like 30 minutes. We've got the tools for you. Come pick them up. Here you go. They're on the house. Just give us a shout out in your video. Not a problem. I mean, I'm not saying it's going to happen every time, but I would rather go into a local hardware store where these people know the tools I'm looking for than for somebody at Harbor Freight to look at me like they've got something better to do with their time. So that's another thing. But no, I completely agree with you. Way back when, I mean, at the end of World War II, people were doing a lot of DIY stuff for themselves. And I don't know whether it was because people were doing this job and people didn't want to take away from people doing this job, and that's why people stopped. I don't completely understand. The first maker I ever met was my grandfather. He built his house with his own bare hands. He built everything that he owned, down to he helped put his tractor together that he used to mow his yard. I mean, all this kind of stuff. He would never buy anything ever pre-assembled. And that's kind of how I've lived my life. And I mean, yes, there is a difference between me making a table and me buying a box kit for a printer to put together. I understand the difference, but there is this satisfaction that is so hard to explain that until you actually do it, I can honestly say you won't understand. When you build something with your hands, that's an achievement. You've made it. Okay, you didn't go down and pay Joe down the street $20 to assemble your bike for you. All right, and now you've got a bike to ride. No, you built this thing with your bare hands. That's pride that you're putting into that. All right, sweat, blood, tears, fine, but that's pride. You made it. All right, and you will always have that you achieved that goal, and that's just it's an exhilarating feeling that you cannot pay for that. You have to do it. Yep. Everybody needs to experience it.
It was great to see us lose it, and it's starting to come back. I mean, that World War II thing, literally back then, it was common for a guy to build his own transistor radio, and that wasn't a special skill. But today, you find someone that can build a transistor radio, and they're the top of the heap somehow.
Yeah.
You know, so, I mean, it's great to see.
Draco, you were talking about that satisfaction that you get from making it, that you can't explain it. You know, one of the best things that I can explain about anything that I make is, or even, you know, when you're kids and you tore something apart. That was one of the best abilities that my parents gave me, was being able to just take something apart, not getting in trouble if I couldn't put it back together necessarily. But, you know, you make something yourself, you tear something down, you modify something, the one thing that adds to that satisfaction that's undescribable is simply the fact that you get a better understanding of how the things work. If you build something from the ground up, like a 3D printer kit, you know, for somebody who's mechanically inclined, building a 3D printer is probably the best way to get into 3D printing, because you understand when something goes wrong, you understand where every screw is on that printer. You get a better understanding of how all the pieces and parts go together and actually make it work. So when something does break, you can be self-reliant to an extent. You might have to go online and ask some questions of people, but you know how to go back to the roots and fix that problem then. That's one of the best things that adds to that satisfaction of, I made this. I can also fix this when it breaks.
Fixing things is a key component that we've forgotten about. With the Walmarts there and the other big box stores, you break something, the most common reaction is toss it. It's easier just to go down the street and pick up one of those. I'm in a rural area, so I don't have one of those big box stores nearby. So 3D printing is key in that if I need something, I can actually build it, rather than having to drive a few hours to the nearest big box store to build it. The repairing, Seattle, I believe it is, has started holding repair fairs. It's not a maker fair, it's a repair fair. And they go into a neighborhood and they ask people to bring in things that are broken. And they find that I think it's between 60 and 70% of the items that get brought in that people were planning to throw out, they were able to fix them. The things that couldn't be fixed are things that had proprietary parts, what have you. And these fairs are actually put on by the city's waste management department, because their goal is to take their trips use of the garbage dump, take it down to zero. That's their long-term goal.
Is it a tornado?
Tornado warning.
Nope.
Is it a tornado, Matt?
Having the skill to repair things, and comes in to just our 3D printing here. I have these little bearing holders I print out. They're for my brother's paper shredder. It's a shredder. It's a $700 shredder. The company that manufactures them will not provide these parts to their support staff. They expect people, if these things break, they throw out the $700 shredder and buy a new one. Their main line starts at $3,000 and goes up. But this, 10-cent part, they're expected to toss the machine out because this breaks. And it took me about a few minutes in Fusion 360, you print it out and give them a handful and say, here you go. So the whole idea of repairing it is no longer part of our culture. I promote the missing R, the forgotten R, because there's reduce, reuse, recycle, and repair.
Absolutely. I put in that same category, by the way. I put in that same category open source as part of the repair mentality. The idea that when that shredder broke, I'm able to actually, if it was open source, I can go get that part and print it out. I also connect that back to, you mentioned a little bit about knowledge, going online and asking a question. Think of it this way, there is absolutely no shame, and there should be great pride in asking the question and answering the question every time, because asking the question saves the person that might be too shy to ask that question, and answering the question means that you're helping someone. And usually it's not one person, it's the next 40 people that read it and didn't comment. on your answer that you helped out as well. So open source, asking and answering questions, and just sharing knowledge. Do it every chance you can.
So we just had a donation again by Colin Make Stuff. I really appreciate it, brother. Not necessary you being here, everyone being here is sufficient enough, but man, the love's coming in. Thank you so much.
We need more weather alerts to go off on people's phones during the stream.
That's the catalyst, huh?
Sorry about that, everybody.
That's all right.
Volunteer firefighter, been one for years. I'm got a beard now. I don't go on calls anymore. But yeah, when your tones went off, I'm used to having tones go off and having to drop everything and take off to the hole.
Yeah, that's what I thought. I thought somebody was in his first due. I've driven an ambulance for several years as a volunteer, so I mean I'm used to that sound.
Yeah. Yeah, that one there, that was wasn't even the fire pager going off. It was my phone's on silent, but apparently the weather alerts, emergency broadcast overrides the silent mode.
It's for your safety.
Yep.
All right, so we have 9 minutes left, or if you want to end now. Anybody have any last minute topics you want to talk about?
Well, it's been great having Dave here.
Dave,
fascinating to see what he's been up to, and love the information. So thanks for joining us.
Yeah, Dave, you're welcome back anytime.
Absolutely. I'll have to do some more of them.
Yeah, definitely. Yeah, I think, again, we had a really good discussion. It helps here recently. We've been getting new people to the streams who kind of specialize in the topics that we're talking about. I mean, as you guys have heard, Dave is a man of many trades, many skills, and I'm sure he can be very useful on other future discussions on the Hangouts.
Absolutely. I love the idea. I love the contributing to everything. Like I said, if you know it, share it.
There was something that Adam Savage said. It was Soto Poto or something. It was see one, make one, teach one. How's it go? Something like that. Anyway, it was really cool because it's kind of like what I do. I see something and I'm like, I got to do that, and then I do it, and then I start making videos on how I did it. So, and that's working out pretty good for me.
Yeah, I can't. I know what you're talking about, and I can't remember what it was. Adam Savage up at Bay Area Maker Faire gets on his preaching kick every year and does a very big deal. You can find most of those on his YouTube page, Tested. And he's a big advocate for makers. One of the biggest I've ever seen, and he has a lot to say about stuff like that. And it's all of it is a point. So I mean.
And by the way, if you're going to make something, I like to tell people, make it 90% out of something you already know, and then 10% of what you don't know. So, if you're going to build a project, use 90% skills you already have, and then learn the next 10%. And that should make the project after that a little bit harder and a little bit harder, and that's how you can get a lot further.
Oh yeah, I mean, we're all about learning about this, but don't bite off more than you can chew. Give yourself a way to enough to succeed, so that when you get to the hard part, it's not going to be so bad.
Right. I completely agree. That's probably a better way of saying what I was trying to say there. But yeah, absolutely. I mean,
I got you.
Yeah. Don't go out and build Rosie tomorrow. Build Roomba first.
That's the agile software development philosophy. Break everything down into smaller pieces and tackle them that way, so that you gain confidence, and that builds your momentum and your velocity to creating the next task.
This was a good panel. I actually had a lot of fun tonight.
Yeah, that's good. The last one that we did. I got to say, the last 4 or 5, they really ramped up energy, and specifically this topic on robotics is just it's mind blowing because that's where we're at.
I think
So,
I think it's a conversation that everybody tuning into this has some kind of interest in 3D printing. At least I would imagine that's what brings us all together for these hangouts, rather than just hearing a bunch of us talk. I think the robotics topic is something that so many people with 3D printers can look at and relate to, or can imagine making something robotic. I mean, you already have a desktop robot making something for you. The next step, the next thought is robotics.
you didn't put the right date down.
I did?
Negative. You used today's date. You have to use yesterday's date.
Did you delete mine?
Negative. It's still there. The comment is still there.
Oh, there it is.
But it's the incorrect date. Now, technically, we will end the stream.
Oh, crap. You're right.
On that date.
Yeah, the stream will be over on 6/16. It'll start on 6/15. Sorry. You know what? I almost make that mistake every stream, but I catch myself.
Yep.
Not this time.
Okay. All right. So thank you, everyone, for joining. Anyone? I do want to make her hang out. Who suggested that? Was that you, Draco?
Yeah, it was Draco.
Yeah, that was me. I've been toying with the idea for a while, and I'm
just not on a Friday night.
Yeah, well, yeah, probably not on a Friday night, but it's kind of a concept I kind of wanted to get out into the community and stuff like that. And this hangout is definitely primarily 3D related, 3D printing related, which is fine. I've got no problem with that. But we do deviate off into different maker stuff, and when it comes to maker things, I do a lot of different stuff, woodworking, stuff like that. And I'm kind of curious to see what the community would think about it, and if they think a maker hangout,
I'm game.
Kind of like this would.
I think the community is going to like it. We just got to do it.
Yeah,
we just got to do it, and I'd say let's start off, instead of trying to be as ambitious as F3D PCH is, let's try to make it like once a month.
And
pick a day midweek, and I got to say that my summers are kind of tight because I'm in Wildwood during the summer, and everything is really busy, hanging out with friends, late night partying and stuff. But off season, not a problem. Yeah, so no, I'm definitely game for that. We can do once a month. Yeah, that'll be real hype. And if we can rotate on different people's channels and all that stuff,
oh yeah, definitely,
it's going to help everybody. Yeah, that's cool stuff. I'm game.
Cool, good. All right, I'll toy with the idea. We'll get together and talk about it. I'm sure we'll find time.
Yeah, we'll just put it out there. Hey, if somebody can start the Facebook page and kind of like the F3D PCH page, and we'll do that. Yep, that's good. All right, so I want to give a special thanks to F3D PCH for accepting me as a member. I think I haven't missed a stream. Seems like I would miss a stream when we did Murph, but technically I was on because JMT brought the phone over when he was live streaming from Chili's, and I made it on.
Yeah, I was hosting during the Murph event, so yeah.
Yeah, I remember that. So anyway, I appreciate you guys taking me in. I appreciate David's generosity. It's a willingness to help everybody in the community, specifically tonight. Willing to take 3.5 hours out of his time because you guys may not know, we start to stream set up ahead of, we're in chatting and getting stuff getting ready. So yeah, I appreciate your time, David, and thank you for the panel, and especially thank you to all the viewers who sat through this. Sometimes, the topics may not jive with everybody, but I think this got everybody pumping and excited. I could get a little bit from the feedback that it was hype energy. So, anybody have any last comments before we end the stream?
See you, everybody.
Yeah. Thanks for having me.
Yeah.
Yeah, have a good night, guys.
All right. Thank you, everyone.